Hello grade 12s, welcome to my channel, and let us revise for these finals. So somebody requested that I do this paper. I may add to it just to make it more comprehensive. So let us go through it. So this is from KZN Practice paper, October 2024. Now, you guys need to take #1 spot in the country, right? Right. And next year, EC must do the same. You need to rise to the occasion, guys. You need to. Instructions, guys. But what is important more than anything is these instructions. Of course, we need to read all and adhere to all. All right. Great. So, question 1, we are dealing with quadratics. In their different forms, and we just solve for x. So we've got 1.1 with 1.1.1. So we have x into x minus 4 equals 21. Okay, don't make the mistake of saying x is 21 and this is 21, because this means this product is going to be the square of 21. Now that's not the case, because we're just equating this to 21. So what we do, we FOIL this out. It's going to be x squared minus 4x minus 21 equal to 0. Now when we see a quadratic, please check the discriminant before you proceed, okay, so that you choose the best approach of how to continue. So usually this can work, okay. So this should be x. Now this is minus 7 plus 3, and that works out nicely. Therefore x must be minus 3, or x must be equal to 7. Okay, so this is it. Now don't be just happy you got this. Go back to the original and please make sure it's copied correctly. So we put a minus 3 there. That's going to be minus 3 minus 4, that's minus 7. Minus 7 times minus 3, it's plus 21. So this checks out. Then we put a 7 in there. This is 7 into 7 minus 4, which is 3. 7 by 3 is 21. So this is the way. And of course, the third mark could be just calculation, factorization, or even getting this quadratic. So usually this would be a 4-mark question, but examiners do their own thing. Okay, great. So how do we score marks in algebra? 3-step approach. 1, it's going to be BODMAS. Okay, both direct and applied. 2, you can factorize. 3, you can use a law, okay, or identity. Okay, so this is basically how we score marks in algebra. So if we use any of those techniques, for example, we factorized here, we get a mark. We used BODMAS, but usually this is the common pathway, so we normally can ignore it if we like. Okay, 1.1.2, the markers, not necessarily you students. So this is x minus 6 plus 2 over x equal to 0. And we are to solve correct to 2 decimal places. So this is a clue that this will have irrational solutions. So we then have to round off to the nearest. Okay, great. So what do we see? This is over 1 over 1 over x over 1, and we're also given a condition that x is not equal to 0. This is just to say this is valid, because when this is equal to 0, means this is undefined. So this is just to cater for that. Sometimes this may suggest that in our solutions, we may end up with some x equal to 0 and x equal to some other number. Then we reject that, okay? But already, if that was a catch, this would not be said. Okay, let's go on and say, what do? We just multiply by the LCM, which is going to be x. Now x times x is x squared minus 6x plus 2 is equal to 0. Now we can see that no factors of 2 can give us a minus 6. So already we can just go on and use our quadratic formula. But if this was not stated, okay, if this was not stated, what happens? We run into problems, don't we? Because here we need to check the discriminant if we are not sure. But you can see from just inspection, one can understand that actually the discriminant is not a perfect square. Okay. So x is minus into minus 6 plus or minus the square root of minus 6 squared minus 4 into 1 into 2. All of that is divided by 2 into 1. Okay. Therefore, x is, now we go to the calculator, minus into minus 6 plus the square root of minus 6 squared minus 4 into 1 into 2 divided by 2 into 1. Okay, what do we get? We get 5,65 to 2 decimal places, or x is, so this one is a very simple calculation, but it can hurt if things are not done properly. So this is giving us 0,35. Alright, we can accept for now, but remember, we've got an original expression to check. Now, what is the utility of this? It says you know these answers are correct. As you proceed, you don't need a memo to know this. You can see this by just your calculations. Now, if we substitute x as this and that in the original, we will see that we need to round off to the nearest integer, okay? Because this is an integer. Not a problem. So we've got 5,65 minus 6 plus 2 divided by 5,65. Now this to the nearest integer is 0. So this is good. Then we can check this one. Please check all of them, because there can be a coincidence. But be very careful. This step is important because we get a mark here. Now, do not find yourself substituting a plus 6 there. Okay? Obviously, you can substitute correctly there, perhaps. But here, because there's a square, you may find yourself just being complacent. Then that would constitute incorrect substitutions. So, make sure the substitutions are correct. So, how many marks are we scoring here? 4. So, the fourth mark is writing our quadratic in standard form. Remember, this is still algebra. So, writing standard formats of things is mark worthy. All right. Okay. Nice. So, we've got 1.1.3. Now, we have here this radical quadratics. So, we can handle them too. Okay, Again, if we look at this, this is over 1, this is over 1, this is over that. So if we multiply by our LCM, LCM becomes x minus 2. So square root of x minus 2 multiplied by square root of x minus 2, it just leaves us x minus 2. Plus, we multiply them, we get 3 root x minus 2 equals 10. Okay, so this is what we get. So obviously with this calculation we need to isolate the radical. Transpose here, we get 12 minus x. Okay, so what do we do here? We can square both sides to get rid of the square root sign. So this becomes 9 into x minus 2 equals 12 minus x all squared. Alright, so let's simplify further. We get 9x minus 18 equals, this is 144. This would be minus 12x minus 12x. It's going to be minus 24x. Plus x squared. Now we write in standard form. We get x squared minus 24 minus 9 is going to be minus 33x. And then 144 plus 18, it becomes plus 162 equal to 0. Okay. So this is what we do. This is what we do, guys. So what do we do now? Remember, this is a quadratic. This dude must not be forgotten, because sometimes you can see how to proceed. But I'm not the guy who gets cold feet, so I can handle this. So we come back and say 162 equals 162, right? Right. So we then press shift, and then we press the fact button. So what do we get? So shift fact, we get 2 times 3 to the exponent 4. Now we know that this is 81 and this is 2. That cannot give us 33, so we need to modify this a bit. We pull a 3 and then we remain with 3 cubed. Then we combine those two, we get a 6. This one is 27. Now we can see that 27 plus 6 can give us 33. So this is it. This is it. So can you see this technique, folks, is quick, unlike needing to do the quadratic. But again, if you don't trust any of your actions from this point on, just plug it into the quadratic. Just make sure everything is correct. Okay, so that is done. So we can say therefore x should be 6 or x should be 27. Again, with this step, we don't just get happy, we got to an answer. We need to run a check so that as we proceed, we know we are doing well. So we put a 6 there. Positive square root of 4 is 2. 2 plus 3, that's 5. Okay, come here, 10 divided by 2, it's 5. So that checks out. 27 gives us square root of 25. That would be 5. 5 plus 3, it's 8. But 10 divided by 5 is 2. So this one gets rejected because the left hand side is not equal to the right hand side. In paper 1, this is mark worthy. Now, any factorizations we perform, remember 3-step approach, and any BODMAS, which is just multiplication, division, whatever, that should be a mark. So we have 1, 2, 3, 4. Now we're scoring how many? 5. Okay, maybe this gymnastic right there. is also good. All right, okay, all right. So this is easy, 5 marks. We move on. Next question is 1.2. Now 1.2, we are given this function. Now this to be a function, it means when we have some values here, constants, and we multiply the function in the denominator, these two should be equal. And as we can see, immediately we look at these, we'll appreciate that this is two functions. Now in grade 12, it helps to look at things this way. Maybe let's make it a bit bigger. But as you progress with your mathematics, you will find that this can actually represent a particular function, which may look very strange, but yeah, whatever. Now we can see that this is a parabola with a grumpy face because the coefficient of the highest power is negative. If we factorize it, we get x into 3 minus x equal to 0. And that means we end up with a graph that is passing through the origin like this. And like that. Okay. So we know that it passes through the origin at 0 and at 3. Okay, you should be able to do this, guys, quickly. And then we know that we've got a horizontal asymptote for the exponential function. So this you don't need a second invitation to do. So this would be the vertical shift, which is minus 4. And then we can solve for x here. We equate the denominator to 0. When we equate the denominator to 0, transpose the 4, it becomes 2 squared. So this gives us a 2. So 2 is probably here. Okay. Now, we know that this graph is actually, its coefficient is some invisible plus 1. So that means when the coefficient of the power is positive, this graph appears above the horizontal asymptote. Okay. That's the most important. And the base is greater than 1. That's an increasing function. So this is something like this. Okay. So this is what we see. Okay. Now the question is, what would be the y-intercept for this function? The y-intercept would be when x is 0, that would be 1 minus 4, which is going to be minus 3. Okay, so this is essentially the functions. Now you need to think about this in grade 12. Okay, this should be your thought process. This should be your thought process. Okay, what color can I choose? This one. Can you see there's points of intersection between these two graphs? And that means this is definitely going to have real roots. Okay, the roots have to be real. Okay, great. So very important. Again, like I said, I will show you someday how to do this function on the Cartesian plane as it looks. We'll see what would be different from this and what would be similar to this, but either way, this is not the level at which you get examined. So please think of it as two separate functions that we can use fruitfully to get around. Okay, nice. And then the question says, when would f be undefined? Now obviously for a rational equation or a rational fraction, for that to be undefined, it means the denominator should be 0. So we start 1.2.1. We know that this is 2 to the exponent x minus 4 equal to 0. So this means 2 to the exponent x is equal to 4. Now if we've got this power right here with the base 2, can we express 4 as a power with a base 2 as well? Yes, we can. So you always get the clue from what you see. So this would be 2 squared. Actually, no. Now when we've got powers side by side, the equal sign, and they have the same base, it means the exponents are also the same. This is it. Now folks, we can check this answer because a mistake can occur. We either check it here, provided this is written correctly. If we put a 2 there, we get a 0, so this works. But take this to the original. This would be 0 on the denominator, and division by 0 is undefined. So we know we are correct, but knowing that this is what we needed to do is the extra mark. Okay, easy 2 marks. So we've got 1.2.2. This one says, for which values of x is f of x equal to 0? Now with a fraction, when you need that fraction to be 0, it means the numerator must be 0. So this means 3x minus x squared must be 0. We can take the highest common factor. We get 3 minus x equal to 0. We can then solve. This means x is 0 or x is 3. Again, we can just run a quick check so that as we proceed, we know we're doing okay. So put a 0 there, everything is a 0. So this means that checks out. We put a 3, that's a 9, minus 9, checks out. In fact, take it to the original. When you make the numerator 0, the whole thing becomes 0. So we know we are going with these marks nicely. Easy stuff. For me, this is a mark-worthy step. It should be considered, but anyway, you only write for 150, so not much can be done about it. Okay, do the last one. 1.2.3. Now we want this inequality. Now that inequality already says 3x minus x squared over 2 to the exponent x minus 4 must be less than or equal to 0. Now here, don't find yourself saying equal to 0 and cross multiplying. Remember, this can be both negative and positive as evidenced by the graph, but you can even check it. Now when the sign is not clearly defined, you cannot multiply across an inequality because it can change, so it gives incorrect answers. So this is a wrong move, don't do it. But when 0 is isolated, we can just place our binomial factors on our things. So this is 3x minus x squared all over 2. Sorry, no. What am I doing? So this would be 2 to the exponent x minus 4. And we are doing the division. Okay, when we solved the numerator, we got 0 and 3. When we solved the denominator, we got a 2. Okay, so that's what we do. And then we ask, when is this 0? It is 0 when x is 0 and when x is at 3. Okay, what happens when you put a value greater than 3? Say a 4, for example. 3 by 4, that's 12, and then 3 squared is 9. No, why am I putting 3? No, we want to put a value greater than 3. That would be a 4. 3 by 4, that's 12. 4 squared is 16. So can you see, smaller number minus a bigger number, we get a negative here. Let's say we're putting a number between 3 and 2, say 2.5. Okay, 2.5 by 3, what is that? 2,5 times 3 gives us 15 over 2, ne? Right, minus, we write 2,5 squared. So we get a positive answer, so that would be true. We put a 2 there, that's a 6. 6 minus 4 is a positive number. We put a 1 between 0 and 2, that would be 3 minus 1, that would still be positive. Then when we put a number less than 0, this would be minus 1, so that becomes a negative number. Okay, great. Can you see? It's exactly the characteristics of the parabola summarized there. When is this one 0? It's 0 when x is 2. When we put a value greater than 2, what do we get? It becomes positive. Okay, great. When we put a value less than 2, it becomes negative. Right? You can just check it out though. Nice. Now what are we saying? We're doing the quotient. So negative divided by negative is positive. 0 divided by any number is 0. Positive divided by negative is negative. Any number divided by 0 is undefined. Positive divided by positive, that's positive. 0 divided by any number, that is 0. Negative divided by positive is negative. So what do we see? We know that 0 is included, but here it's undefined, so that's what we do. In between we get the solution, so that's what we do. 0 is included. To this side the solution exists. Okay, so we can make a conclusion that therefore x must be less than 2, greater than 0, or x must be greater than, this one must be equal to as well, greater than or equal to 3. That's the solution. Okay, so we get a mark for these, and that's how we get those 3 marks on offer. But remember, we are told whatever we used to determine our answers, we need to show. So you cannot answer a 3-mark question with an answer only. But in functions, when the graph is given, we are interpreting the graph, you can do this. But in algebra, when there's no graph given or table given, we then have to show how we did it. That's just a trick. Okay, easy stuff otherwise. And obviously, guys, one can still pull up this graph right here. Remember, the graphical method is still applicable. It is still applicable, so we can copy that and paste it and say, well, maybe let's move our solution a bit down. So we can say the graphical method can also be shown, and we can draw the same conclusions. I like to show you guys these 2 techniques because I know they are applicable in a whole lot of areas, and you can score very good marks if this is done. Okay, let's proceed. That was a nice question. 0, 1,3. And in fact, a question like this one could easily be asked as in, what would be the domain of f? Okay, and the answer, you can just say x is an element of all real numbers except x cannot take 2, because we saw that this thing becomes undefined. Remember, division by 0 is undefined. So this is another way this question can be asked. So they can just say, write the domain of f. So this says, perform these calculations and then write down the final answer. So that could be for 3 marks. Okay. The rest is pretty easy, and this one can say find the x-intercepts of f instead of just saying f of x equal to 0. And you know how to do this. Okay, great. Now that one is more of an interpretation of this function, so to speak. Okay, so can you see, guys, even though functions are still ahead, this is still coming. This would be a higher grade question. And if you watched my video on 2005 examinations, paper 1, you will appreciate this. And in fact, it becomes much more easier to approach this with more courage. Okay, let's do 1.3. 1.3 says we've got 2 to the exponent x plus 1 plus 2 to the exponent x is equal to 3 to the exponent y plus 2 minus 3 to the exponent y. So from just an inspection, we can see 2 to the exponent x is common there. 3 to the exponent y is common. So we can factorize by taking out the highest common factor. But first, in our three-step approach, we need a law. This is 2 to the exponent x times 2 to the 1 plus 2 to the exponent x equals 3 to the exponent y times 3 squared minus 3 to the exponent y. Can you see this is the law or identity? Great. One can easily say this is BODMAS. So, I don't know why, guys, my voice is a bit, I don't know. It's actually throaty, so this is always the case when I'm doing something. Anyway, now, what are we doing here? We can see that, well, we can factorize step 2. See, the three-step approach, guys, it's not a fluke. If you know what this is, you are on your own way upwards. Okay, so this is what we end up with. And if we simplify further using step 1, BODMAS, those are like terms. So this is 2 to the exponent x times 3 to the 1 equals 3 to the y times, this is 9 minus 2, this is minus 1, that's 8. But now we see this is 3 to the exponent 1, this is 3 to the y, there's some similarities there. 2 to the x is related to this because 8 is a third power of base 2, right? Great. So what do we see? This is 2 to the exponent x times 3 to the 1 equals 3 to the y times 2 cubed. Okay. So again, if you didn't know this, you could just take the 8 and say equals 8, and then you hit shift. And then you hit fact. This would already give you 2 cubed. So you can use your calculator when you're not sure. Then if it doesn't work out, then use logs whenever you need to. Okay. Now logic tells us, guys, that if we have this product equaling this product, but within these products we see that there is some power of base 2 and there is a power of base 2. So it means those two should be equal, provided there is a power of base 3 also within those products like that. So this implies that 2 to the x is equal to 2 cubed and 3 to the y is equal to 3 to the 1. Therefore, when we've got powers that are equal and they have the same base, the exponents are also equal. Okay, so this is a nice form of simultaneous equations where we apply, our exponential rules. Again, guys, don't be excited you got to the answer. The original expression, which you need to know how to copy correctly, needs to check out. If we put a 3 for x, that would be 3 plus 1, that's a 4. 2 to the exponent 4, that's 16. 2 to the exponent 3, that's 8. 16 plus 8 is 24. We come here. This is 3 cubed, that's 27. Minus 3, that would be 24. So 24 is equal to 24. So these two actually check out. So those are the first 2 marks. And we're only getting 3. Wow. Well, this step, when we factorize, it looks like this is where the marks are. But again, even this logic here is important. So guys, I don't know. Certain things are implied. Not a big deal. Even to simplify to this, the mark can be there. Or even using laws of exponents. Remember, every time we apply this, mostly these ones in algebra, give us a mark. This is the what you call the common pathway arithmetic in an algebraic sense. So you may not get a mark. So essentially, I could accept those 3 marks like this. But where I put the asterisk, this is where the marks can be scored. Alright, not a big deal. So let's finish up. So we have here 1.3. Okay, so 1.3, we are given this dude. We see this is quadratic. And then we see a linear thingy. And then we see this QX. And then we see this plus 10. Right. So what does this remind you? If you remember the question I have shown you guys on that 2005 stuff, this is it. Long division or remainder theorem or factor theorem. Now we call this one the dividend. This one becomes the divisor. This one becomes the quotient. Okay? And this one becomes the remainder. Okay. Now, this is us looking at this in an algebraic sense, like using a rule or some sort of a law. But if we look at this, this is a parabola. Like any other parabola. If we put an x value that is not a factor, we get a point on the graph. And this would be giving us the x value. If we take the opposite sign, of that constant inside that bracket, we can say this is the x value. And this would correspond with this y value. Remember that that's what we proved on the remainder theorem, that when we divide by the divisor, that polynomial is effectively equal to the remainder. So now this helps a lot, because if you understand what is going on, you just know this is it. So obviously, if we just want to think about it nicely, so we will have our x plus 2. We've got 5x squared minus kx plus 16, and we are dividing here. So as we divide by the stuff that comes here, all of these things cancel and leave us a remainder. And here we will have our quotient in terms of x. So this suggests that our dividend, we can just say capital letter D is equal to the divisor, small letter d. I'm just choosing my own notation now. This is going to be multiplied by the quotient q in terms of x, of course, plus the remainder. So from understanding long division, or essentially factor theorem or remainder theorem, knowing how things work out, this is exactly what we see here. So somebody can ask you, give you a quadratic expression and say, write this quadratic expression in this format. You just have to do it. Usually they may suggest the divisor, or you may have to find it yourself, but that means just find anything that is not a factor. That could work. But to avoid too many different answers, this may be somehow projected but whether direct or indirect. Now, we understand what we are dealing with, and we're told now where k is a constant, yes, and then q of x is a polynomial. Question is it a polynomial? Yes, it is. But normally, if this is a quadratic and this is a binomial linear factor, this should also be binomial and linear. Okay, well, that's what we see with quadratics when we factorize them. Okay, you saw above. Now, this is what we have, and then the question says calculate the value of k. Okay, so that is easy. We can handle that. So again, folks, this may look like a very difficult question, but it's actually a very simple question. And let's attend to it nicely. So we have 5x squared minus kx plus 16 equals x plus 2 times q of x plus 10. Now this implies that 5 into minus 2, remember we take the opposite sign of this one as a value of x, all squared minus k into minus 2 plus 16. When we divide by the divisor, what do we get? The remainder. So this should be equal to 10. So this is why you need to understand these kinds of things, guys. So I may have looked like I was bluffing when I was showing you this thing, but you can see immediately how useful it is. Right. So this implies that 2k is equal to, this is 36. We transpose, we get minus 26. Therefore, k gives us minus 13. Nice. Okay, so now how do we run a check in a situation like this? I mean, this is a bit hectic right now. Well, to run a check, we just do the remainder theorem nicely. So we take our divisor x plus 2, and then we put this one. This is 5x squared. Now, if this is minus, and then there's a minus, it becomes a plus 13x, and then plus 16. Then we ask, how many times does x go to 5x squared? It goes 5x times. 5x times x is going to be 5x squared. 5x times 2, that becomes 10x. And remember, there's always an invisible negative there. So this becomes 0. 13 minus 10, it gives us 3x. We drop that dude. Then we ask, how many times does x go to that? It goes 3 times. Okay, 3 times x, that is 3x. 3 times 2, that is 6. Again, there is a negative hovering around. Then that becomes 0. 16 minus 6, that's 10. Can you see? We can see clearly that therefore 5x squared plus 13x plus 16 is going to be equal to x plus 2 times 5x plus 3 plus the remainder. So this is our check, basically. So the check is a bit complex this time. But again, you can choose how you do it. So it helps, guys, to check your answers, because if this doesn't make sense, because remember the key is that we need to divide by x plus 2 in this expression. When we substitute the actual value of k, then we must get the remainder as was suggested, and this ties up nicely. And do you see that this is binomial and linear? So understanding these things is key, folks. So again, substituting the minus 2 is a mark, and equating to the remainder is the second mark and the k value. Of course, the check is what you would do on your rough work. So guys, this is how easily we could get these 25 marks. But of course, some areas can cause you to panic a bit. But I do believe if you practice hard enough and you understand these things, and in fact you always make an effort to understand a question, this makes life a lot easier. Okay, great. Someone may say, what are the coordinates of a particular point? Let's say when this is divided by that, and this is what we see, and then they can say, what are the coordinates of this point? You will then write that this is -2:10, because when there's a remainder in a quadratic, this is just any point on the graph with the x and the y coordinates. So you need to understand this in that sense. Otherwise, you're so let's see question 2. Okay, let's try to tackle this question 2 as fast as we can. So we're given an arithmetic series. So we have an AS. We've got -11, -7, -3, plus 133. So what are we looking at? This is the A, which is the first term, and this is the last term. We call it TN, or you can say it's the last term like that. Now, since this is arithmetic, we know that in between these two, we must have some common difference. So -7 plus 11 is going to be 4. So this is -3 plus 7, that gives us a 4. So we know that the common difference is 4. So we are ready to hustle this. So we've got 2.1. 2.1 says, how many terms are there in the series? Very nice question. So we know that Tn is A plus n minus 1 times d. This implies 133 is equal to -11 plus n minus 1 into 4. And then we just sort it out systematically. Okay, so this implies we have 4n here equals, now we can just simply say 133. Now we're going to add, this is -11 minus 4, that is -15. So when you transpose, it becomes +15. So we get 148. Way, my lord. Okay, so yapanyaza, it blinked. So this is 148. Therefore, n is divided by 4, it gives us 37. Okay, now we answer the question. The question said how many? Therefore, there are 37 terms in the series. So always make a habit of writing your conclusion. This is just a means to an end, but we need to write a conclusion. That's a mark because it answers the question. Finding the common difference was key, and substituting into the formula properly. So this is how we get these 3 marks. Nice and easy. Now we can do 2.2. Now 2.2 says calculate the sum of the series. That's easy. We know Sn is equal to n over 2 into a plus l. Okay, so we know that this is S sub 37 is going to be 37 over 2 into -11 plus 133. This implies S37 is equal to, do we even need to say that? No, we can conclude. So 37 over 2 into -11 plus 133 we get 2,257. Now we don't know the units, but it's any units that this represents. So we leave it like this. Okay guys, so substitutions and answer, easy 2 marks. So this is an easy 5 marks. Here the examiners are just giving you a gift for a bit of a sweat in question 1. Alright, now at this juncture guys, I would like to introduce another question in the arithmetic stuff that was shared to me by my students, just to highlight how much revision is probably necessary for this kind of a question. Just hold on. Okay guys, so this was the question by my students. So I don't know from where it was taken, but we'll just do those 2 questions just to highlight something, okay? Otherwise we'll spend a lot of time doing everything. Okay, this is now taking a revision. I don't know from where this paper came, so you can look for it elsewhere. Alright, okay, alright. Now, let's see. This is 2, 1. We have a sequence. So this is 2, 5, 8, and then it continues. But if we look at it quickly, this is nothing but arithmetic, because there's a 3 between these 2. There's a 3 between these 2. So once that difference is common, we know that this is arithmetic. We can say therefore the sequence is an AP, arithmetic progression, with A equals 2 and D equals 3. That is very important. Okay, so this is a very important stuff here. Now let's answer some questions. So this is 2.1.1. It says if the pattern continues, write down the next 2 terms. Obviously, the next 2 terms is going to be the same common difference here of 3. So 8 plus 3 is 11. And then between these 2, we would still have a 3. And 11 plus 3, that would be 14. Okay? And then this continues. So we can just write here T, this is 1, 2, 3, 4, is equal to 11. And then we can say T5 is equal to 14. Okay, looks like we're getting just 1 mark for this. Not a big deal. 2.1.2. Okay, now this is where the higher grade component came. It says prove that none of the terms of this sequence are perfect squares. Okay, now how do we do that? So of course we need our general term. Sometimes it helps to look at it, because if we don't, we may not know what we are dealing with. This implies that Tn is equal to A is 2 plus n minus 1. We saw that this is 3. This implies that Tn is 2 plus 3n minus 3. This also implies that Tn is basically 3n minus 1. Now that's the general term. So what can we do? We can safely say, look, we understand that if we want to show Tn in a different light, we can just take the square root of Tn and explore that. So what we do on the one hand side, we must do on the other hand side. Now, maths allows us to just play any tricks. So we just want to explore what happens. Now here we want to simplify this so that we can identify exactly what direction does it take. If we factor out a 3 here, we end up with n minus a third. Right. So what do we see? This, essentially, we can say, therefore, the square root of Tn is going to be, we use exponential rules here, times the square root of this thing. You can say n minus a third. Okay? Now, what is the significance of all of this? Now, guys, you know what? The critical step here was this moment. Because remember, a perfect square, it means we can take a square root. And we must get a rational number solution. But now, what do we say? We see that this is irrational. Remember, square root of 3 is non-terminating. So this is irrational. So it will never give us a whole number. This, knowing that n is an element of natural numbers. Now this means from any natural number, we're taking a recurring fraction. Remember 1 over 3 is recurring. It's 0.33333. So when you take a square root of a recurring fraction, maybe let's just say x recurring, it becomes irrational because it's non-terminating. So we know that, okay, any natural number, when we subtract a third, we convert it to a recurring fraction. And the square root of a recurring fraction is non-terminating, meaning it's irrational. So this means there will never be a perfect square here for all values of n element of natural numbers. So that means we can't have a whole number resulting from this. We can say, well, we can say Tn, the square root of Tn, the square root of Tn will not yield a whole number, right? Or we can say an integer, whatever, a whole number, since the square root of 3 and the square root of n minus a third are both irrational for all n element of natural numbers. Nice. I think this is good. And then now what would we say? We can say therefore Tn is not a perfect square for all n element of natural numbers. Now we made a conclusion. So this is a bit technical, okay? But if you understand your maths, you would know that this is indeed true, because understanding, algebraic expressions in simplified format, you can make a conclusion about what direction they take, okay? All right. So basically, guys, we know that getting the Tn is important, and taking the square root and simplifying it, it's also important. And then this explanation is key, and that final conclusion is key. So we've got 1, 2, 3, 4. So I do believe here it's going to be substitutions. So this is how these 5 marks could be scored. Okay, I'm just showing you ways of dealing with this problem nicely, okay? But my students were a bit more intense on this. They actually surprised me. This is what they proposed. two of them proposed that, look, we can just say Tn is equal to some perfect square, meaning take any perfect square, say 4, for example. The most important reason for all of this is because this is a perfect square. So this is now proving by contradiction, if you ever heard of such a thing. Now, let's have a look. What is Tn? This is 3n minus 1. Obviously, this means the first step is common to all these calculations. Because without it, it's ridiculous, isn't it? We can say equal to 4. Then we solve for n here. We see that 3n is going to be 5. Therefore, n is going to be 5 over 3. Now we can say now, this is also suggesting that n is not equal to a natural number. Okay? Because this is not a natural number, it's a decimal. We can say if this is the case, we can say therefore Tn will not yield a perfect square for all n element of natural numbers. Because we can see that when we pick any perfect square, so the key is to pick any perfect square. One can use a 9, can use a 16, can use a 25, can use a 36. You choose whatever you want. So this is a technique that my students impressed me with, because I was like, you know what, these guys are good. So the first 2 marks are there, equating to any perfect square. That's the 3rd mark. And the conclusion, that would be the 4th mark. And then maybe the value of n, that would be the 5th mark. Okay, so this is how they looked at it. But here's yet another way one can think of this situation. It can be very interesting. Now we can just say, well, 3n minus 1 is equal to some perfect square. Now we're dealing with it algebraically. Now what are we doing here? We can see this is a quadratic, so we get n squared minus 3n plus 1 equal to 0. And here we can see no factors of 1 can give us a 3, so this is already irrational. So we've got 2 options here. We can just check the discriminant. B squared minus 4ac is, now this is minus 3 all squared minus 4 into 1, like that. This is 9 minus 4, that would be 5. Can you see this is not a perfect square? We can say therefore delta is not equal to a perfect square. Okay, which means n is not an element of natural numbers, because or maybe which implies that n is not equal to any natural number, and we can make a conclusion therefore Tn is not a perfect square. I'll just say PQ. Okay, PS, sorry. Because now I'm running out of space, is not a perfect square. Alright. So this is another way of looking at it. As you can see, the utility of the discriminant is important, guys, because this helps us to understand what is going on. Because remember, n is an element of natural numbers. So when this does not give us a natural number because of the quality of the discriminant, we know that even if we solved for n, we would still not get a rational number solution. So that's another way. So guys, I will just propose yet another way for you guys to explore and make your own conclusions. So make your own conclusions. So now try solving this quadratic from here. solve it using the quadratic formula. Just say n is going to be minus b plus minus, b squared minus 4ac all divided by 2a. Okay, so this is for you guys to practice. Okay, because I can't do it all. I need to give you some tasks. And obviously, when you get to the solutions, try to interpret this and answer the question, okay? Most important is to answer the question. So obviously, guys, this is how we would score those 5 marks, and in those different ways. Again, here, if we chose the root of the discriminant, substitutions into the discriminant and its answer, and our conclusion is essentially those 3 marks. The first 2 is for finding the general formula, essentially. Okay, so I hope you guys understand and you can appreciate how nice this thing is. Now let's go back to our question. Okay guys, we are back to our question paper. So you can understand that even in sequences and series, guys, algebraic techniques need to come in. This is just a logical technique from my students. Very interesting. These guys are brilliant. And then this could be applying algebra, nature of roots, to understand a function and how it goes, because this could be a function. And then we can use the discriminant, we can use the actual roots using again the quadratic formula. So you can clearly appreciate that you keep applying principles of maths everywhere, so you don't forget just because you're in a different section. Yes, there are some questions which are particular to that, but some questions that are difficult are definitely applying yet another section or other sections of maths, as demonstrated by these questions. Okay, let's get to question 3. We'll just keep taking one extra question to try and expand on each question, to give you the best experience of your revision here. So we are told that the first term of a quadratic number pattern is 61. And we've got tk that is equal to 4k minus 26. So this is linear. Now this is the sequence of the first differences. Yes, they are linear. We know that. Okay. Great. So what do? We want to write it down and say the quadratic pattern is like this, 61, and then it continues. So, but we know that between this 61 and the next one, what do we have? We've got T1 equals 4 into 1 minus 26. This would give us 4 minus 26, it's minus 22. Okay, so 61 minus 22 is what? It's 39. Okay. Okay, since it was not given, let's just choose a different color. And then we know again that between this one and the next one, we will have T2, which is going to be 4 into 2 minus 26. This would give us 18, minus 18. Okay? And then 39 minus 18 gives us 21. Then this keeps on going, but since this is quadratic, what we're trying to get to is the common difference of the first differences. So minus 18 plus 20 minus 22. Okay, let's just say minus 18 plus 22. It gives us a 4. Okay, that would be the common difference of the first differences. And theoretically, you know that this is 2a giving us this. This would mean 3a plus b gives us this. And we know that a plus B plus C gives us that. So no need for any manga business. So can you see, guys, once you get the question in order, you start answering. So 3.1 says, determine the second and third terms. So we can say T2 is going to be equal to 39. T3 is 21. Okay, so we're getting 2 marks, and showing how we did it, we get an extra mark. Okay, a gift from the examiners. This could easily be just 2 marks. Now we're told to determine the nth term of the quadratic number pattern. So we know that 2a is 4. Therefore a will be a 2, which implies that 3 into 2 plus b must be equal to minus 22. Therefore b will be minus 22 minus 6 is going to be minus 28, which also implies that 2 minus 28 plus c should be equal to 61. Therefore c is that. So we've got 61 plus 26. That gives us 87. So therefore Tn is going to be 2n squared minus 28n plus 87. Okay, good. So what are we doing here? We need to check this expression. In the sequence that we got, does it represent that sequence? Okay, let's see. Let's just say term 1, for example. So we've got 1 into 1 squared minus 28 into 1 plus 87. It gives us 61. So that checks out. Let's check the third term just to avoid coincidences. You can even check all if you like. So I'm not sure what I'm doing here. I made an incorrect substitution, so I'm getting 21. So this definitely proves that this is correct. So can you see, guys, you don't need a memo to get this right. With just your calculations, you can see how this one goes. Okay, great stuff. So let's see, 3.3. We are told here, determine the value of the smallest term of the quadratic sequence. So what is the smallest? Minimum. Okay, now remember this thing is quadratic. So what does that mean? It means on a Cartesian plane we can have stuff like this. And then our quadratic has a positive y-intercept. Okay, so this is what we have. But remember, this one, because it's quadratic, what do we know? We know that we do not have a y-intercept. So this one does not have a y-intercept. Let's join this. Okay, so this one starts from T1. Okay, it starts from T1. That's the origin there. And then obviously T1 is 61. We saw that. So this one starts there. And we will see that since this is a smiling parabola, because the coefficient of the highest power is positive, so this is what it looks like. And then it just keeps going because there was no end. Now we can't put y over there, unfortunately. What we have here is n and tn. So we need to adapt our x's. So can you see, if we want the minimum value, that means we want the value at the turning point. What would be that value? That's what we want. And obviously this is right on the axis of symmetry. Also, you may ask yourself, what would be that number there? So, can you see, guys, thinking of functions helps one to, sort out problems of this nature. This is not an easy question, but it's one that can be solved while one understands. The reason for all of what you see on the graph is because n is a natural number. So how can we do this? Well, we just take our Tn is equal to n squared minus 28n plus 87. This implies that Tn is 2. We factor out the 2. This is minus 14n plus 87 over 2. Okay, I'm completing the square, even though this is not examinable, but writing this in vertex form can help me to sort out this. So we take this, take the sign, we have that, 7, we square, plus 87 over 2, then we immediately take out minus 7 squared. Okay, know how to do this, guys, easily. So this is this n minus 7 or squared. Is it a plus or a minus? Let's see, 87 over 2 minus 49 gives us minus 11 over 2. And then we can see that it implies that our Tn is, we redistribute the 2, and then this is going to be minus 11. Can you see? This, the opposite number here would be that number there. It would be that number there. Okay? And minus 11 is the minimum value, because if you look at it algebraically, you will know that this bracket is either greater than 0 or equal to 0, because this is a perfect square. But when you say minimum, we want the smallest value that this one takes. Therefore, it would take 0. Right? 0 multiplied by any number is 0. And guess what? That would be our minimum. So, like I said, simplified algebraic expressions can give a direction. Okay? Great stuff. So what can we say? We can say, therefore, the smallest value, the smallest, what is this? What is the value? So therefore the value of the smallest term is minus 11. So we must always answer the question. So the question was not on what number it is. This is T7, but what we are interested in is the smallest value. So writing in vertex form is a mark, and essentially answering the question. So easy, 2 marks. Remember, this is termed not examinable. So this simply says this is your own thing. So you may not show these steps. You just write this out. You will not be punished, because writing in vertex form is examinable. I don't know why it is not examinable to do that, but I guess it's the steps that they don't care about. They care about the final result. And then the value of the smallest term would be minus 11. Okay. Now that is it, guys. So this is how one could take these 9 marks nicely. Okay, that was easy. But now let me just show you some options. So you can say here the smallest term is equal to 4ac minus b squared over 4a. This comes before we take the square root so that we can create the quadratic formula. So this is still good. So we have 4 into 2 into 87 minus into minus 28 squared, all divided by 4 into 2. What do we get? So we've got 4 into 2 into 28. No, 87, sorry. Minus into minus 28 squared divided by 4 into 2. And the answer is minus 11. So this is another way of dealing with the problem. Very easy. And the other way would be to say n is minus b, which is minus into minus 28, divided by 2 into 2. So we know that 28 divided by 4 is 7. Then we take this to say, well, Tn is going to be 2 into 7 squared minus 28 into 7. Okay, okay, plus 87. Yawena. Okay, so this should give us minus 11 as well. So one can do many things here, guys. At some point, one may want to approach it using differential calculus, but using calculus, this would mean we take the derivative here. We can just say Tn prime would be equal to 0, which implies when we differentiate here, we get 4n minus 28 is equal to 0. We can say, therefore, n is equal to 7. Then we say T7 is going to be equal to 2 into 7 squared minus 28 into 7 plus 87, which should be equal to minus 11. So this is also another option using calculus in grade 12. But whatever you do, get the answer right. And as you can see, writing in vertex form is much more simpler, and this one also is much more direct. Others involve 2 steps each. Either way, if you answer the question, you are sorted. Okay, now while on the quadratic, I'd like to go and fish for another question my students showed, so that we can enjoy some difficult questions to just give some flavor to what we are doing. Okay, guys, so let's have a look at this question 2. As you can see, this is from the EC September 2024. So at least it's easy to tell where this one came from. So let's just go for it. 2.1, we are given a quadratic pattern where we have minus 5, minus 4, minus 1, 4, and it continues. And if this is quadratic, we can immediately do the first differences. This is 1. This is going to be 3. This is going to be 5. And then also these ones are not standing still, they are ongoing. The difference between these two is going to be 2. Difference between these two is going to be 2. And this proves we do have a quadratic. Okay, now we're going to not waste time. Once we have sorted it out, we start answering. 2.1.1 says we need the nth term. Easy. We know that 2a is equal to 2. Therefore, a is 1. This implies that 3 into 1 plus b should be equal to 1. Therefore, b is basically minus 2. This implies that 1 minus 2 plus c should be equal to minus 5. Therefore, c is going to be minus 5 plus 1 is going to be minus 4. So what do we say? We say Tn is going to be n squared minus 2n minus 4. Now we need to run a check. Is this a representative of our sequence? Okay. Now let's see. Let's look for T1. We've got 1 squared minus 2 into 1 minus 4. That gives us minus 5. Let's look for term 3, for example. You can check any terms, but do more than 1 at least to ensure that this is good. So the third term is minus 1. So we know this is good, and that is good, that is good, that is good. So what do we get? 4 marks. Very easy. And of course, this needs to be shown, because we don't want to show up with just a 2a and we don't know where it's coming from. Okay, be very careful of that. So we are doing 2.1.2. Says calculate the 35th term. So this means T35 is going to be 35 squared into 2. Sorry, minus 2 into 35 minus 4. Therefore, we just go back and substitute. So this gives us 1151. Ooh. Okay, all right, okay. So this one, correct substitutions and the answer. In fact, we're only getting the answer, okay? Not a problem. Bakwainyana. 1.3. Now it says, which two consecutive terms of the first difference sequences, or first differences sequence, will have a product of 1155. Now this is the higher grade question. This is there to make you sweat a little bit, okay guys? So a little bit of planning is important. Remember, the first differences make up an arithmetic sequence with a common difference of 2. So this is very important. Now what do we say? Well, we are saying the product of any of these two, whatever they are, must give us that. So what do we know? We know that, well, this is suggesting that T of n minus 1 minus T of n, sorry, not minus, but multiplied by, should give us 1155. Okay, easy. So for you guys, think of Tn times Tn plus 1, because that would be the one ahead, right? Don't know why I'm squashing myself. Think of Tn times Tn plus 1 equals 1155, okay? Practice this one. Okay, so I'm throwing you some stones every now and then, guys, so that you get engaged, because don't look at something in just one method only. Now, guys, here We can decide to do the Tn formula here, or we can do it on the side. I mean, it doesn't really matter because we don't know the Tn formula for that. But for me, I will just simply say this is something like this. The A here is what? I'm trying to think. Tn minus 1. Okay, maybe let's not start here. It's going to hurt before we start doing this. Before we start doing this, let's just wait a bit. So we know that Tn there is A plus n minus 1. Sometimes don't take a difficult path when there's an easy one. So the first one is 1 plus n minus 1 times 2. This implies that Tn is 1 plus 2n minus 2. We can say therefore Tn is 2n minus 1. We then take this path, you know. We can say then this is what we are given, and we go for it. So this implies that we will have 2 into n minus 1 multiplied by 2 n minus 1, giving us 1155. We simplify this, we get 2n minus 2 minus 1 into 2n minus 1 equals 1155. Simplify further, we get 2n minus 3 into 2n minus 1 equals this, and then we FOIL. This becomes 4n squared minus 2n minus 6n. It's going to be minus 8n plus 3. We can say minus 1155 equal to 0. This means we've got 4n squared minus 8n minus. If we take out 3 there, we get 1152 equal to 0. Now we can divide by 4 and see what happens. We get n squared minus 2n minus 1152 divided by 4 is minus 288 equal to 0. The question is, can we factorize? Well, I'm not a coward. 288 equals 288, and then you do the things. So what do we get? We get shift fact. It gives us 2 to the exponent 5 times 3 squared. Now this is 32 and 9, and that cannot give us a 2. So we need to break this one. 2 to the exponent 4 times 2 times 3 squared, and then we combine those two. When we combine those two, we get here 2 to the exponent 4, that is 16 times. This one, it's 9 by 2, that gives us 18, and 18 and 9 can give us 2. So this implies that we have our quadratic easily factorized. So n, the bigger number, takes the sign of the middle term. Nice and easy. So we continue here. This implies that n is 18 because n is an element of natural numbers. So that's why we disregard the negative answer. So it's not a negative integer. Okay, good. This goes into your rough work, of course. Don't show it. Now, what are we doing, guys? So we can say, therefore, the numbers are, or the terms are, because the question said terms. Now we take this into any simplified version if we like, but we can just put it into the original. This is going to be 2 into 18 minus 1 for the first one, minus 1. And 2 into 18 minus 1. This is going to be 2 by 17, that's 34, minus 1, that's 33. Then of course this one is up by 2 points because the common difference is 2. So this should be 35. Answer. Let's see, 33 times 35 gives us 1155. So they check out. Okay. And that was a means to an end. Third mark. Yikes. Yikes. Substitutions. That would be the fourth mark. Interesting, isn't it? Interesting stuff. So obviously, guys, for creating an equation, it's a critical step, but you can see higher order questions when applied. You have to derive the equations. In fact, this was a means to an end, but this one is key. Yes. So you have to derive the equation. Okay. And then those equations you solve simultaneously, or however you think about it. See, construct our own path, we go on and we sort according to our knowledge and we get the answers. So guys, I hope this helps to seal the fact that if you apply your knowledge, you will win. But if you are scared to do so, you might just lose. Okay, let's get to the next question. So we're going back to our question paper. Okay guys, let's start question 4 here so that I don't waste my space. But for you, you start on the new page. So we're continuing with our revision paper. So we have 4.1. 4.1, we are given Q, which is equal to the sigma when P starts from 1 of 3 to the exponent P of x plus 2, all to the P minus 1, and that goes to infinity. So because of this thing, it means Q is a sum to infinity. And if that's the case, it means this is a convergent geometric series. So this is the convergent GS. So can you see, guys, very important, and for this to even converge, it means R must be less than 1, greater than minus 1. Of course, I'm just highlighting these to, help a student who is struggling here. But those who are already high flyers, they know that you don't even need the second invitation. But let's just explore a bit more, just to prove to you that a bit of an inspection is very important. We know that once we have a base to this particular exponent, this would suggest this should be the common ratio, right? But the catch is that this one is also raised to the exponent P. And now that says this can't be the common ratio, but we need to consider that as well. So what is the best approach? It is to expand to 3 times. Q is going to be the sigma when P starts from 1 to infinity of 3 to the P into x plus 2 to the P minus 1. This suggests that we've got 3. This would be 1 minus 1, 0, so it is just 3. So we go on, we put a 2 there. If we put a 2, we get a 9 into x plus 2, right? And then we just need 3 terms. Now we put a 3 there. This is 27 into x plus 2 squared plus this dash 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 continues. But remember, this is the sum to infinity. So there will be some convergence somewhere along the way. Easy stuff. So we can say, well, Q is a convergent geometric series with A equals 3 and R equals, we can just take this one and divide by the previous one. This gives us 3 into x plus 2. Interesting stuff. So can you see, guys, it is very important to okay, so Q is a convergent series such that A is 3 and R is 9. So we can work it out however we want. Now that we have made sure we understand the question, we now are ready to answer some questions. So 4.1.1 says determine the values of x for which the given series converges. We know that, well, this is when R is less than 1. Greater than -1. Now we've already shown the determination, so we can just write 3 into x plus 2 less than 1 greater than -1. We divide by 3, this is -1 over 3. That would be less than x plus 2, which is also less than a third. Maybe we can just sort it out. So we transpose the 2, the -2 minus a third. Then we're going to have -6 minus 1. It's going to be -7 over 3. So the sign doesn't change. X. We transpose this. It's going to be 3 by 2. That's 6. 1 minus 6. It's going to be -5 over 3. Okay. So, great. So that is it. That is it, guys. So please, I don't understand why you are given dedicated spaces, honestly, because they are smaller than, you need time, man. You need space to showcase your knowledge so that even if you get stuck, someone can see though it took a mistake rather than no knowledge at all. Okay? All right, okay. So obviously, guys, this situation R, determining at 8 is a mark, and the constraint is a mark in the final answer. So 3 marks in the bag. But sometimes someone may say 2 marks for this final answer and then 1 mark for the common ratio. The rest of the gymnastics one should already know, because this is the rule for convergence. So we can consider this one as the mark and that as the mark and ignore the rest. It doesn't matter. As long as the answer is correct, we have those marks. Okay. So 4.1.2 says, calculate the value of Q if x is like this. Now you can see that this x value is positive. So you can see that x is greater than 0. But what did we say? X must be a negative number between -5 over 3 and -7 over 3. So this is already saying Q is undefined, because we cannot solve. So we can make an argument, we can make a calculation. It really depends on how we see it. Okay, so let's say, well, R is going to be equal to 3 into 9 over 4 plus 2. This gives us 3 into, This is 8 plus 9, that's 17 over 4. This gives us what? 3 into 17 over 4. This gives us 12,75. Can you see? So we can say therefore R is not less than 1 and certainly not greater than -1. Okay. So if this is the case, it therefore means the series is divergent. In fact, let's just put it this way. Let's just put it nicely. This looks a bit dirty, so we can say therefore R is greater than 1. And it is outside the domain. If this is a divergent series, we can say therefore Q is undefined. Or maybe is not determinable. Is not possible to calculate. Maybe let's just say that. Because there's no convergence. There is no convergence. So obviously, guys, this is important. The interpretation, either we say that or we can say the series is divergent and then conclude that we can't calculate the sum to infinity. Okay. So another student would want to look at it in terms of the x value. So we can say x here is greater than 0. So we can say here x equals 9 over 4 implies that x is greater than 0. We can say therefore x is not between 5 over 3 and -7 over 3. So we can say therefore series is divergent. Can say therefore Q is indeterminable. Nice. So obviously, guys, interpreting that the series is divergent that we cannot determine and proving that this is outside the domain is also how those 3 marks could be scored. So there are many ways of killing a cat as long as you kill it, because a careless student would just plug this there and calculate, and that is a catch. Okay. Be very careful. So it's a bit of a nice question. So let's do 4.2. So the geometric sequence, in a geometric sequence, the sum of the 9th and 10th terms is 6 times the 8th term. See, again, a higher grade question. What is it doing? It's saying derive the equation yourself and then solve it. So we know that in a geometric sequence or geometric progression, it is such that Tn is Arn minus 1, right? Right. So we can say now T9 is going to be AR8. Sum is addition. AR9 is equal to 6 times AR7. Right. So this is very important to do. And then we can see that AR7 is a common factor to every term that we see here. So we divide by that. What do we see? A's divide out to 1. R7 takes just 1 there. Plus A's again divide out, and then what happens? 9 minus 7 gives us R squared. And then we remain with 6. You can see this is a quadratic, so we can write it nicely. So this means R squared plus R, we transpose the 6. get 0. Like any quadratic, we can attempt to factorize, but of course pay attention to the discriminant. But if you look at this is bigger than the middle term and there's a 1, there is a possibility of winning, but be very careful. 6 is 3 and 2, and 3 must carry the sign of the middle term. So we can say therefore R is going to be 2 or R is 3. So what is the question? It says find the value of values of R. So these are 2. We take them as we see them. So again, guys, this is a very nice question, easy 4 marks. Obviously, writing out the equation is important. Coming up with a quadratic by doing the gymnastics is important. Nope, not necessarily coming up, but remember 3-step approach, guys, 3-step approach. BODMAS, factorize. So when we factorize, we get a mark and those 2 individual values. Okay, this is how mostly marks are scored. So that would be the science or the logic behind how we score marks in maths in general. All right, okay, all right. So that was a bit of a nicer question. So obviously, guys, if no mistakes have been committed, this could be some lovely 10 marks for that question. Of course, the trick was here. This one was a tricky question. So if you are not careful, you would just answer. But if you are careful, you answer. So that is a typical higher order question as well. All right. At this juncture, guys, I would like to show you yet another question from my students that highlighted something on convergent series in an application, so to speak. Then we can say safely we have practiced enough for these sequences and series, just to give you a bit more. Okay, guys, here is another question. We're going to look at this question 3. Okay, as you can see, it comes from March 2016. Okay, that is the reference paper for this question. So we want to see how we can apply this geometric sequence that converges, because sometimes a question like this is what happens. Okay, let's try to answer this within these next few minutes, so that we can take our function walk nicely. Now I'm not going to add any more questions here. We'll just go all the way to the end of the paper to avoid making it too long. We're told here, Chris bought a bonsai miniature tree at a nursery. When he bought the tree, its height was 130 millimeters. Thereafter, the height of the tree increased as shown. Okay, during the first year it increased by 100, second year 70, third year 49 millimeters. Okay, great. Now we are told here that Chris noted that the sequence of height increases. This is too thick. Namely, 170, 49 was geometric. Oops, nice. Now, during which year, that's the question, during which year will the height of the tree increase by approximately 11,76? So this is easy, because now we're dealing with this geometric sequence there, and we can see it's decreasing. So this is typical of a g that is less than 1, because it decreases. And remember, a geometric sequence is sort of like an exponential function, so this is already telling us the base is less than 1 of that thingy. And remember, the base, when it carries the exponent, is what? Is the common ratio. So the common ratio is less than 1, so that forms a decreasing exponential function. So always think about this in that sense. So this is technically a convergent geometric sequence, okay, or geometric progression. So let's have a look. Now this is a question on Tn. Okay, so we can just say, well, we've got a geometric dons here. let's just say geometric progression or sequence, whatever. GP is from 100 to 70 to 49, and then it keeps going. And what do we see? We can see that A is going to be 100. We can see that R is going to be 70 divided by 100. This is essentially going to be 7 over 10. Even if we do this 49, 7 goes 7 times, goes 10 times. So the 7s cancel out. Then we remain with 7 over 10. And that is exactly what we have. Now let's answer 3.1. 3.1 says, well, we know that Tn is ARn to the minus 1. Now Tn is this 11,76 equals 100 into R, which is 7 over 10 times n to the minus 1. Okay, so we can simplify this and say this is basically 7 over 10 to the minus 1 equals 11,76 divided by 100. Okay, try to isolate this thing. Now what do? We can see that what we want is on the exponent, so we need to introduce logs. Now what we do on the one side, we must do on the other side. Okay, good. So let's sort it out. This implies we can see that using logarithmic rules, this is going to be stuff like that. Equals the log. Okay, so that's what we have. Now using our logarithmic rules, this implies, in fact, now I'm going to move, guys, very quickly. So I'm going to move quickly. So I'm going to say n is going to be the log. Now the base is going to be this 7 over 10. The number is going to be 11,76 divided by 100. But there was a negative 1, so we add 1 to that thing. Therefore, n is. So again, guys, you need to understand logarithmic rules, or else shesampama. Yeah. Kuzokhala impama. Utlola yengwe impama eshesanga ntate. Itlobolaya. So you must watch out. So this is, remember, n is an element of natural number, so we take the whole number before the decimal, or we round off to the nearest when necessary, but usually just take the whole number is 7. So we answer the question, we can say, therefore it will be during the 7th year. During the 7th year, the tree will increase. Okay, the tree will increase its height by approximately 11,76 millimeters. Okay, can you see? We can apply our things nicely. Okay, all right, okay. So what can we do now? Answer the next question. Okay, let's first do the marking. 4 marks. First of all, finding the common ratio is key, but, well, this can be marked there, and then we say the substitutions, 2 marks. And of course, applying logarithmic rules and doing all the gymnastics. I mean, we can mark it here, we can mark it there, but I think they are heavy there. and then we answer the question. So that is it. Easy 4 marks. But remember, the marks can be anywhere, guys. But it's important to look at certain things properly. Alright, so 3.2. Question says, Chris plots a graph to represent height h in terms of n of the 3 in millimeters in n years after he bought it. Now it says determine a formula for h of n. Now that is a higher grade question also, because now it's going to be a little bit naughty, but the marks are hiding the fact that you have a lot of things to do here. Well, let's have a look. We know that the height in terms of n is going to be the initial height, which is 130 plus. Now, can we say sum to infinity? This one will give us the definite answer, so we can't use sum to infinity because we will have a value. But now we want a general formula, so we're just going to write Sn, okay? We then simplify. This is 130 plus. Sn is going to be A, which is 100. Right, into 1 minus, remember the common ratio is 7 over 10 to the exponent n. So when r is less than 1, this is the formula we use. This is over 1 minus 7 over 10. Okay. So we sort it out nicely. H of n is 1/8 into, now we know that this will sort out that numerator there, as good as 100 divided by 1 minus 7 over 10. What do we get? 8,000 divided by 3. So this is as good as 1,000 into 1 minus into 7 over 10 to the n, all divided by 3. Okay, that is what we get. Now we continue and say, well, we're not done. We need to get things done. So we need to simplify this so that we can see what this represents. So obviously we multiply that by 3 using the common denominator stories. So this is going to be basically over 3. So 130 times 3 is 390 plus 1,000 into 1 minus 7 over 10 to the exponent n. Then we break that bracket nicely. So guys, systematic simplification, you know the 3-step approach, right? So this is 390 plus this one, it's going to be 1,000 minus 1,000 into 7 over 10 to the exponent n, all of that over 3. Okay, so we will have, therefore, h of n is, these are like terms, so they will do the honors, Bodmer style. Then whatever the result, we divide by 3. So this is going to be 390 plus 8,000. So this is 1,000. This is 1,000. 1,390. We can split this if we like and say over 3 minus 1,000 into 7 over 10 to the exponent n, all over 3. Right. In fact, let's just show it nicely so that this is a simplified version. Like this, it can cause a bit of situations that we don't like. So this is as good as 1,000 over 3. Okay. Now this is more simplified and we can even determine its direction. So this is it. Okay, good. So now what did we have to do here? We're scoring 3 marks, folks. Now this substitution into this SN formula was key, and the final answer is key, and we can just say the entire substitutions including this 130 over there. So this is how these 3 marks are scored. Okay, but now let's have a look what is going on here. If you just think of an analogy of what is going on here. Now it helps, guys, to really picture things nicely. If our h in terms of n is equal to, we can just rearrange this so that it makes mathematical sense in a functional sense. Right, think of this one, plus 1390 over 3. What do we see? This is an exponential function where the coefficient of the power itself is negative. Now this suggests that this graph appears below the horizontal asymptote. And what makes the horizontal asymptote here? It is the constant or the vertical shift. Right. And now what about the base? The base is itself less than 1. So when the base is less than 1, greater than 0 with this is an increasing function that appears below the horizontal asymptote. So on the Cartesian plane, we have something like this. So we can say this is basically h of n in this case. Again, I mean, this is from essentially Tn, so that would be the value there. So maybe we can even write Tn, perhaps. And then this is not x. I like x so much, so this is n. Now, if this be our horizontal asymptote, right, and then we always show this with a broken line. So this is at that number exactly 8,000 over 3. Sorry, not 8,000, but 1390 over 3. That is that value over there. And then we're saying this is an increasing function that appears above the horizontal asymptote. So obviously, if we look at y-intercept, if this is 0, this is already negative, right? So we will take it from that value. So let's find out what is the story. So when this is 0, this becomes 1. Let's see, 1390 divided by 3 minus 8,000 over 3. This is 130, so the x-intercept is positive, so it means this graph is going to do stuff like this. Let me think. Okay, that would be the y-intercept actually. The y-intercept is positive, so it means the x-intercept will be negative, okay? So this is the graph that we will see. Okay, but maybe not quite nice. That's better. But now where does the graph start? It starts from T1. It starts from T1. And what is the value of T1? Well, T1 is literally when we put a 1 in there, what do we get? So this is going to be 1390 over 3 minus 8,000 over 3 into 7 over 10. Essentially, so that is 230. Okay, that would be fine. So this is exactly what the graph looks like. And then we know that this portion right here is not part of the solutions. Why? Because n is an element of all natural numbers. So it doesn't start from 0, it starts at t1. And so this is essentially an exponential graph that is increasing in nature, and it appears below the horizontal asymptote. Okay, so can you see this is why this person was able to do this graph? So from there we can appreciate what is going on. So this is again rough work for enrichment. So you must not find yourself drawing this, but this is what he drew. It would look like this. Okay, nice. Now let's go on. It says now, what height will the tree eventually reach? So that's the sum to infinity. Now we can answer this question here. 3.3. Well, one can actually use this. We can say now the eventual height is going to be equal to essentially h to infinity, because it can grow and grow and grow and grow. Okay, what does this mean? This is going to be 1390 over 3 minus 8000 over 3 into 7 over 10 to infinity. Now remember guys, this, once you have a proper fraction going to infinity, that means as we increase this, what happens? This approaches 0. So this is going to be 1390 over 3 minus 0, because any number multiplied by 0 is like that. So this is going to be basically 1390 divided by 3. So this is 463,33 millimeters. Remember that was in millimeters. Is that all, guys? Yes, it makes sense. It does make sense, because this thing converges on this value, and then after this value nothing seems to change. Okay, nothing seems to change. You understand? Now the question is, we said this 1390 over 3 is literally the horizontal asymptote. But of course, because this is a real life situation, it means, although we don't really touch that number, but it's so close to it, isn't it? It's so close. Because we rounded off to 2 decimal places. This is not exactly equal to that number, but it's closer to that number because we then had to do that. So this means this is the convergence here. So after this, nothing is going to essentially change. So remember, some things in the real life sense look a bit strange, okay? Some things in the real life sense, they look a bit strangish. What is important is to understand what needs to be done, okay? So what do we get here, guys? Substitutions, knowing that this is going to come down to 0, and then the last mark. And remember the unit of measurement is key. But someone may just say essentially the height is going to be basically the sum to infinity. Oh yeah, wait a minute. Wait a minute. I'm thinking, yeah. One, this may say this is going to be essentially the 130 plus sum to infinity. So this is 130 plus a is 100 divided by 1 minus 7 over 10. So let's see. 130 plus 100 divided by 1 minus a third. Not a third, but 7 over. Yeah, we call it 7/10. So we get the same answer. Ne? So this is 463,33 millimeters. Okay, so one can also approach it this way. It's not a problem, knowing that you will have to eventually do the sum to infinity. But here we can use the formula as given and just understand what is cooking. So guys, this also marks one of those nice questions where you have to apply your knowledge into some real life situation. So this would be an easy 10 marks if you know your work, but it could be a painful 10 marks if your work is, you know, shaky. All right, guys, let's go back to our question paper and continue. Okay, guys, so we go to functions. Now we are going to get to the place that is much nicer. But again, I was just trying, guys, to give you some comprehensive revision. It was really nothing out of the ordinary. So let's go. Given the exponential function, we see once the exponent is negative, we always try to write this with a positive exponent. G of x is basically 2 to the minus 1, so that the exponent is positive, eventually proving that g of x has a base that is less than 1. Okay, so this is the most sensible way we can look at this. So algebraically, we don't accept negative exponents, so we always try to change this. But of course, in grade 12, there's not so much fuss about that, but you just need to understand that this is a decreasing function. Why? Because the base is less than 1, but greater than 0, whereas the coefficient of the function itself, meaning the coefficient of that power, is some invisible 1, which we don't write, and it's positive. So this is saying this is the graph that appears above the horizontal asymptote, and it's a decreasing function. So this is the sketch that we can draw, and the horizontal asymptote is the x-axis, and this is the origin. So this is the graph that we get. Okay, so the graph that we get is like this. So it crosses at 1. Okay, that's it. That's it. This is G. Okay, nice. So can you see, guys, this is very easy. Once you understand what is going on, we must just get it done. Now we don't waste any more time. So 5.1 says determine the equation of G inverse in that form. It's a 2-mark question, so we can write it out nicely. We can just say G inverse is such that y equals the log. Okay, the inverse of a log is an exponential, so the base is 1/2, the number is x. Done. So if we simplify this by inspection, remember a determination is by any means necessary, so there's no specific dictation, especially if the question is just 2 marks. We can just do our thing nicely, so we get 2 marks for the answer. But if you like, you can go the long route and do the calculation. It's still okay. But you see, once you know what to do and you've done enough homework, this becomes effortless. Now, is G inverse a function? The answer is, well, if we somehow decide to draw any vertical line across this line. Oh, by the way, where's the line of G inverse? I didn't do it. Okay. Now, G inverse is going to be stuff like this, guys. Okay. It's going to be stuff like that. This is G inverse. Okay, nice. Now if we draw any vertical line through the graph of this function, this is any vertical line, meaning it's a line that is perpendicular to the x-axis, and it's any vertical line. So this is our test line. Okay, now what do we see? It intersects our graph at only one point. So this is essentially this graph passing a vertical line test. So we can answer this question and say yes, it passes the vertical line okay. So again, easy 2 marks for agreeing and stating whatever is necessary. Okay, or you can even say a vertical line drawn through that graph will only intersect the graph once. You can have a way, a lot of ways of expressing that. Or you can even tell about the relations, because a 1:1 is that relationship spells out a function. But a function can have relations like many to one, like parabolas and stuff. So be very careful. Relations are not quite a strong point when it comes to deciding what is a function and what is not. Okay, so let's just move on. 5.3. What do we have? We've got point M, which lies on the inverse. Okay. So we can see this is 2. So this is probably a point. So I choose IP color again to show this point. So we can see that this is above 1. So this could be this point right there. Okay. That could be that point. So that this is 2. Okay. Now this is already saying the corresponding x value is right around there. So this is that value there. So we want to find out what is that value. Calculate the value of A. Not a problem. So the inverse function is basically given by the log of a half. The log of x to the base half. Careful how to read this correctly. Sometimes it helps, man, to be proud of your stuff. Now we know that this point M lies on this graph. Okay, so point M with A and 2 is such that 2 is equal to the log of A to the base a half. So we simply convert to exponents. So the base takes its position over there. You don't show what I'm doing now. And the exponent will just jump into its position as well. So you can see that A is basically a half to the exponent 2. Therefore, A is basically a quarter. Can you see this would make sense to be a quarter? Okay, because it's half of a half. Makes sense. Even its position. When you have a sketch, you can even picture what is going on to know that this is what you would expect. Okay. Then of course substitutions over there. So 2 marks. Nice and easy. Can you see, guys? Once you know what to do, you just cruise. You are on cruise control now. Can you see? Even appreciating functions from the previous sections is already an added advantage. So this is 5.3.1. Please ensure that the numbering is correct, especially if you are not writing on that dedicated reticular space. Now we're told here, M prime is the image of M which lies on G. Can you see? Now remember, these are inverses, and inverses are symmetrical about, inverses are symmetrical about this line. Okay, this is just an approximation of our inverse line. So this is the line y equals x. This is what this is. Now, this is suggesting that, well, our m prime is a mirror image of this one, right? So if that point is over there, so we can see that this point should be over here as well. Okay, maybe there. All right, great. Obviously, guys, this is not perfect at the moment, but it's just giving the vibes. So this would be the m prime. Okay, can you see m prime is on G? And these are inverses. So that means you just switch the coordinates. And remember, inverses have this relationship that we need to also appreciate. We need to appreciate this relationship. What color can I choose here now? Light blue. Remember, these points, if we draw a line joining those 2 points, those 2 points need to be equidistant from the axis of symmetry, which becomes this inverse line. And 2, that particular situation must be such that we've got 90 degrees here. Okay, this must be a perpendicular line. Interesting stuff. So this becomes very important when we're dealing with analytical geometry. So meaning those 2 points are not only, those 2 points are not just inverses, but if we draw a line across this inverse line, that line should be perpendicular to the inverse line such that the distance from one point to that midpoint and the other one to that midpoint is the same, meaning on the inverse line we will have a midpoint of a line connecting those 2 points. So this is, wow, a detailed analysis if you ask me, and you need to appreciate this, guys, or else you will be killed. So it says write down the coordinates of m prime. So m prime is just the inverse of that point. So that point was 1/4 and 2, so this one is going to be 2 and 1/4. Okay, makes sense because you will see that this is below 1, although I didn't draw it so nicely, so that should be 1/4. This is ahead of 1 because remember the inverse cuts at 1. Of course, this one is not really saying the message nicely because of the drawing, but this should be ahead. So, easy 2 marks. Oh, 1 mark. They are mean. They are mean. They are mean. But I mean, all we had to do was just to switch. Okay. And I saw inverses, guys, being taught nicely at grade 8. We missed that grade because of the stupid OBE. I don't know why they brought that nonsense anyway. So this is, again, wrong. See, be careful of how you number. Even though you're performing the right gymnastics, you must also consider the right don't. Again, you see, that was an easy flow here because we understood our work nicely. Now let's see, if h of x is g of x, shifted 3 units. Ay man, qalile ukungihlanyisa ke. Ayisafuna usuka now. Yo, iyaphapha. Remember, that is a shift to the left, and this is a shift upward. So it says if h of x is basically the graph of g shifted 3 units to the left and 2 units up, write down the coordinates of the image of m on h. Okay? So now we're going to take the coordinates of m and transform them to that image. So we can just write image of m prime is going to be, we take the x coordinate, we shifted 3 units to the left, take the y coordinate, we shifted 2 units up. So we can say therefore M prime image is going to be -1:2. Now this is going to be 8 plus 1, that's 9/4. Okay, that's okay. So basically this is just this point shifted this way and then that way. So it makes a bit of sense. It makes a bit of sense. So again, no transformations, guys. That's a very easy topic. Transformations can either be translations, meaning shifts, like in this case. And then, of course, we get 2 marks here because we were supposed to just write down. But here, this is just the method to do it. Shift to the left when you're taking a point directly, you subtract. A shift up when you're looking at a point, you just take it up by adding 2. Very easy. Now, that's how we score those 2 marks, guys. And this was a nice and easy 9 marks. If you ask me, there was nothing really serious here. But obviously, this is a typical higher order question. You will die if you don't know it. This one is not really. If you understood inverses, it's not really tough. But it is interesting, don't you think? Yeah, so guys, I think we don't need to revise this any further. We've done a lot of questions in the channel where we explored exponential functions, so I don't think we should waste time. And we can see where they apply. Sequences and series, sum to infinity. We saw an exponential equation there that is even shifted about. So very interesting stuff. So there's a lot you will see in physics. If you look through the channel, some of the questions I've done, I've shown some logarithmic equations when you're dealing with acids and bases. It heavily applies the logarithmic equation and you will appreciate it. It's not like an inverse relationship per se, but it's a logarithmic relationship depending on the type of function you get. And you will also appreciate that the hyperbola that we're about to go to now applies heavily in electric circuits or where we have inverse proportionality like Newton's laws of motion, acceleration and mass. You know, all of those things, man. You'll just appreciate the fact that if you don't do maths, physics becomes a nightmare, especially in those interpretatory type of questions which are higher grade in nature. Anyhow, let me drink something before the dinner. But anyway, guys, we're doing well, so let's try to speed up a bit. Okay. Now let's handle this question 6 without wasting time. Now we have a hyperbola and we know where these apply, right? For example, let's just think of the applications, say Ohm's law. This is Ohm's law, meaning the voltage is the constant. So what do we get? We will see that I is inversely proportional to 1 over R. And how do we do that graphically? So this is something like this, right? But what do you notice? You will notice that this would be, say for example, R, when we're looking at that in the denominator, and then we are looking at I, the dependent variable. Can you see this equation is hyperbolic because remember this is constant. Is it not constant? It is constant. And is the x not variable? It's variable. So can you see this is a hyperbolic equation? Inverse proportionality literally is a hyperbolic equation. That's if you think about it nicely. That's if you think about it nicely, guys. So be very comfortable seeing applications of certain things, and you will see that we'll never touch this and we'll never touch that as well, because we can never have a zero current per se when we have a potential difference and a current in the circuit. So this cannot be zero. Why can't it be zero? Why can't R be not zero? Because therefore the current would be undefined. If we have a potential difference, we don't have a resistance, and then we're talking about a current. That's ridiculous, isn't it? So that is the story. And again, we cannot have a situation where we have a zero current, yet there's a potential difference and a resistance. Not quite. Again, that explains why we can't touch there. So this is just to expand your knowledge. Otherwise, what do we see here? We write this in standard form. F should be 1 over x plus 2 plus 3. That is the standard form that we appreciate and should be able to do. Okay. So obviously, what do we expect? We expect a sketch like this. The numerator is positive, so this is in the first and third quadrant. Horizontal asymptote is going to be at, the vertical asymptote is going to be at -2. Okay, and then the horizontal one is going to be at 3. So remember, this is not necessarily to scale, so we just know that this is 3 there. Maybe let's write it elsewhere. Okay, we can write it here, it's fine. I don't have space. That is 3x, but I don't like that one. I don't like that one. We can just write this is y equal to 3. Sometimes when you feel like it's messing with you, you just don't do that, force things. Now the graph should be here and there. Okay, so this is what this is. So the graph is a decreasing function, literally, and it has negative gradients. That's the stuff that needs to be understood. So, so this would be the origin. This would be the x, this would be the y. So at least, guys, taking a bit of time to appreciate what you have, it makes life so sweet. So this is f. You can just write f somewhere. This is f. Okay. Easy. Now we're not going to waste too much time. This already highlights the fact that the y-intercept is positive. It highlights the fact that the x-intercept is negative. So if we find anything strange in these questions, then we know that this is ridiculous, okay? Or at least our calculations are incorrect. So we have f of x. Let's write it in standard form. That's what we have. So let's start answering. 6.1. Write down the y-intercept, okay? Now the question says write down. Now the question is, guys, what is the y-intercept? Are you allowed to just write y is equal to some value? Or you are supposed to present it in the ordered pair? Is that what we are supposed to do? So maybe let's say some y value. So which one is the correct one? Can you choose one or the other? Or you may have to choose one strictly. For me, the word intercept, it's a point on the graph. And a point has an ordered pair. So from strict definitions, if I was to be the marker, I would take down someone who doesn't do this. But there is some discretion in this regard. So I don't know, guys. These are things you want to confirm with your teachers, because these are the gray zones where no one is exactly sure what is expected of them. So we can just write y-intercept is going to be, the x is 0. Then the y, when we put a 0 there, what do we have? 3.5, so that's 3,5. So 3,5 is 7/2. Okay, So we get 1 mark. Very easy stuff. 6.2. It says calculate. Now you see, even though this is 2 marks, we can't just show up with the answer. We have to respond to the question properly. So we know that essentially x-intercept is such that 0 is equal to 1 over x plus 2 plus 3. This implies that minus 3 over 1 is equal to 1 over x plus 2. Now we cross multiply here. Please don't show this thing. I'm just showing you. So this is minus 3x minus 6 is equal to 1. Therefore, I don't have time to waste now. X is going to be minus 7 over 3. Can you see we established that our x-intercept should be 0. Now my answer would be, therefore the x-intercept should be minus 7 over 3 and 0. That's how I see things. That's how I understand things, because the y and the x-intercepts are points on the graph. And the point on the Cartesian plane has both x and y coordinates. But anyway, you look through those guidelines. You see, this is where the guidelines come in. They give a guide when there's confusions, right? But they're not really rules per se. Someone can decide, okay, I can take it as just x is equal to, and I can take it as a y is equal to, because automatically the y value is 0 for the x-intercept. Automatically the x value is 0 for the y-intercept. So there's many issues here. But again, guys, for me, when you have an issue like this, I would rather you go through it this way. You go through it that way, because you never know when someone is grumpy. Just always think of an examiner as some grumpy individual who's just trying to take you down or tear you apart. Of course, substituting a 0 there is good, and essentially presenting the final answer properly. But obviously this can be given here, this can be given here, but this second mark can be anywhere. Again, ask some people who know maths better than I do. People like Mr. Chauke in Immutable Academy. He has a YouTube channel. You can just pop a question there. Hey, how to respond to a question like this? He's a mathematician, so he knows the curriculum. He is a teacher. He will give you a better perspective than I could. For me, I give you what I feel because of what I understand from what I was taught, okay? But that may have changed. Be careful. You can also ask people like NTE, Ntabiseng Maimela. Brilliant lady there. She can give you some, proper intel into this. That's with Lee, or long distance learning with Lee. That's Lihlohonolo Subin. She's very good as well. So you can pop a question to her. You may find something. I'm giving you the people I would recommend you check out if you want to really do well. But of course, time is almost against you. But it doesn't have to have a look at certain things in the way they present them. And maybe you might learn just right before the exams, okay? You can also check the virtual tutor. Very good gentleman there. You will learn a lot there, okay? But he's also a bit, not so available, just like I will soon not be so available as well. And who else? Bright Young Brains, Levi, excellent. You can ask him a question on this, because honestly, guys, this is where I feel these are the questions you need to make sure you have an answer to, so that when the question comes, you can boldly answer. But also, at this point, you may also want to correlate with those exam guidelines, because I don't know actually what is better, because I may be wrong to be this strict. I may also be right. I don't know. So you need to check this out. Who else can you ask this question? Who can give you a straight answer? Maths with Amin, or Mr. Amin Hendricks from PE. That actually is a true mathematician, in my opinion. He's probably a teacher himself and maybe a PhD in maths. The way he presents his work is excellent, guys. But I don't know, you guys don't seem to like people who really give you quality. I don't understand, but hey, it's up to you. You can check that gentleman. You can just pop a question in the YouTube channel on any one of his videos. I'm sure he should respond and give you a better perspective as to how to answer a question like this appropriately, rather than, you know, choosing certain options, just being exact if you want to stay that way. Well, that's the safest way sometimes. Okay. Who else? There's a gentleman also who is showing up a little bit more now on my feeds as well. Is Math and Science Aid. That gentleman gives you a comprehensive approach to solving mathematical problems and physical science problems. So you may learn a lot there. Yes, time is a bit of a factor right now, but it doesn't hurt when you have a topic that you don't get and he presents it. Check those out and maybe you might get a better perspective than you can see or find in my channel. Who else is good? I can tell you about, it's the MV tutors. How can I forget those guys? Check those guys out. They give lessons, they solve past exam question papers, both long question papers in full and some questions, you know, in sections if you need that. Check those guys out. Tulu and Figure, they will give you, you know, real stuff. Now I'm giving you also, guys, if you notice, giving you people that you would often ignore, because I mean, I do not need to introduce the popular individuals like Mr. Mlungi Singosi and Kevin Maths and Science. But here's another guy that you might want to check out if you want to really be good at this. And the one thing, the advantage about him is that he's quick. So if you're a quick student looking for just a perspective, he's the right guy to look at. I think his channel is just Math and Science. And then he has that emblem of organic chemistry models like this. You know, stuff like that, I think. Very good gentleman. I don't know his name, unfortunately. So just check him out and you might just be a genius in a moment before your exams. Alright guys, this is just to give you a few number of people that I would recommend, because I know you would often ignore them and jump for the popular ones. For me, it's not really a contest of popularity, but it's working together. So please consider others. You might learn more than you think. And you may realize that you're actually gaining more than you would gain in those popular platforms. But it doesn't mean take anyone for granted. If those guys are popular, they're already proving themselves that they give quality. But you don't want to limit yourself to their predicaments or their weaknesses in these subjects. You also want to take strengths from some other people so that you can get better. Okay? Because I mean, I personally am not a teacher, so I know I would not give a better perspective than many others who are probably teachers, and others have experience in teaching the subject. I'm just what you call a fanatic. It's a wannabe mathematician, but I'm not. I wanna be a teacher, but I'm not. Okay, be very careful of me. All right, let's do the last question, guys. I've taken a little break by talking a lot. Now we need to sketch the graph and clearly label all intercepts with the axis and any asymptotes. So very easy. So we already saw what we are going to do about this one. So we can make that horizontal asymptote. So we know that this is at -2, and we can make this one the vertical asymptote. No, horizontal asymptote. What am I saying? This is the horizontal asymptote. The other one was a vertical asymptote, so this is at 3. Okay, this is the origin. This is X. This is Y. Okay, so now we know that this graph is doing stuff like this. And then it's also doing stuff like that. I want it better. Okay, so we saw that this is basically at -7/3. And we saw that this is at 7/2. Okay, and what else do? We label the graph F. So how do we score the marks? The marks basically, it's any one of the asymptotes. The other mark is any one of the intercepts, be it the y or the x, and then the shape of the graph. But please make sure it's labeled so that we know what function are we doing there. So a very easy question, but I've had to just expand your knowledge a bit. So that was an easy 6 marks to score. Okay, so maybe I will take a bit of a break and chow something before we continue from here. This is the big girl of the functions usually. This is where the big boys and girls start crying. Okay, let's see if we will cry also, because it's easy to cry, isn't it? Yeah. Okay, now we're told sketched below are the graphs of k, of x. This is a parabola because the highest power there is x squared. Okay, and we've got a straight line graph. So this is the bump and place of functions usually, and this is where the troubles can come. Now graph of k has a turning point at -1 and 8. So this is the one, it's given. S is the x-intercept of h and k, so that is the common one. So at S, we've got 0 and some x value, whatever that is. But knowing this one, we can solve actually that x. So when you make y 0, we transpose -4 divided by -2 is going to be just 2. Okay, that is the story. So this one is determined. Be careful not to assume everyone knows what you did. You are just working out, flexing. Remember, these diagrams are provided in the answer sheet as well. So annotate them so that as you answer, someone can follow what you are doing. Now, graphs of h and k also intersect at t. Okay, we can see that point t there. So this is some x value and some y value. All right, okay, all right. Not a big deal. So what do we know about this straight line? It cuts at 4. That would be the y-intercept there. Okay, that's it. And then we see that this is a grumpy face parabola. So what does it say about our a? It just says that our a is less than 0. So if we ever calculate, we expect a value less than 0. Yeah. That's fine. That's okay. Now, folks, there's not much. We just go in and sort it out. 7.1 says calculate the coordinates of x. Remember, the question said calculate. You can't just write the answer only. Even though this is trying to throw us into that direction, we are not allowed. So we can say at S, it is such that 0 is equal to -2x plus 4. Just choosing that one. This implies that -2x is equal to -4. Therefore, x is equal to 2. But what was the question? Coordinates. So this means S is going to be 2 and 0. Be very careful. Present your answer properly. This is a mark. This is a mark. That was a means to an end. Okay. So at least when the question is quite clear like that, you don't waste time. So 7.2 says determine the equation of k in terms of the vertex format. Now that is by any means necessary, but remember, don't be too charismatic. Sometimes trust your calculations. This is 4 marks. This is already saying more likely 2 steps here. Okay, so we know that k of x is going to be a into, this is going to be x. Now what is the x coordinate at the turning point? It's a 1. So we write it as the opposite sign, and then we square that, plus the y value there, it's 18. So this is the vertex format. So we know we have a point now, which is our newly found S. If it is wrong, we're in trouble, right? So we're saying at point S where there's 2 and 0, it is such that 0 is equal to a into 2 plus 1 all squared plus 18. Okay, so let's simplify a bit. This means this is 9, a is equal to 18. Not 18, but minus 18. Therefore, a is minus 2. Can you see we expected an answer that was negative, and there it is, so it makes sense. So what is this, guys? Substituting those guys, or writing, let's just say writing it in that manner, then substituting the point and getting the final answer is key. But now the question is, what the hell? 4 marks. Or Aspalangi equation, can it? So we can say, therefore, k of x is minus 2 into x plus 1 all squared plus 18. That would be the final mark. Because remember, we have to answer the question. No matter what we need in between, it can be mark worthy, but we need to write the answer nicely. Easy stuff. Now we've got 7.3. We are told to determine the value or values of x for which k of x is less than h of x. This means k of x must be below the graph of h. Now where do we see that? We see that here. I skipped a question. We are here. Determine the coordinates of t. Okay, this is simultaneous equations, stuff that we already knew. So we know that at t, it is such that k of x is equal to h of x. It's a point of intersection. This implies that now our parabola is given to us in the expanded form. So this is good, minus 2x squared. Can you see our a confirms our hunch? And it means it confirms the calculation also. 2x squared minus 4x plus 16 is equal to minus 2x plus 4. Now with quadratics, we always write in standard form. So we transpose everything. So we've got minus 2x squared minus 4x plus 2x is going to be minus 2x. 16 minus 4 is going to be plus 12. Equal to 0. So we can divide by minus 2 to make it easier. So we get x squared minus x, plus x minus 6. Equal to 0. Again, we can factorize. I mean, this one is too simple. So if you start sweating here, then you're not serious. Ne? Good. So we can say, therefore, x is equal to 2 or x is minus 3. So what do we say? What do we say? What do we say? What do we say? This is suggesting that indeed that one is minus 3. So over here, over there, we've got minus 3. Nice. So this is minus 3, and now we need to find the y value. So what do we say here? We can conclude that therefore x at t should be -3. We can't choose the positive one because that's that point. We can say therefore y at t is going to be, we can use this one, h of -3, so this is -2 into -3 plus 4. This is 6 plus 4, that's 10. Sorry, therefore t is this point, -3 is to 10. So this is the point in the second quadrant. X is negative, y is positive, so we can accept this one. Say, okay, 10 is certainly below 18, so we can accept it. We can accept it. All right, okay, all right. That's wonderful. So in fact, let me just show you something. If we drop this one too, if we drop that one, what do we see, guys? So this is -1. Now we know that this distance should be equal to that distance, right? Because that is the axis of symmetry. So -1 shifted how many units? 2 minus -1 is going to be 3 units. So -1 minus 3 gives us -4. So this is -4 there in that x-intercept. So we can actually determine that x-intercept nicely. Forgot to show you that, using the axis of symmetry. But we can solve it algebraically also. We just use the arithmetic one, but we can do algebra. So anyway, guys, those were 5 marks. So equating these two was key. And then coming up with this composite function, writing it in standard form, maybe here, 2 marks. And then sorting up this 3rd mark, sorting up that 4th mark, but maybe not there even, but just substitutions there. 4th mark, and we needed to present the coordinates. So that could be 5 marks. But again, if you have the question, the marking guidelines here, you just look through them and get the answers nicely. Now 7.4, we need to determine when is this like that. So obviously, guys, this is happening under these circumstances. So guys, if we look through those sections that I highlighted, you will appreciate that the graph of H is above the graph of F and here, and then in between those 2 points T and S, the graph of K is above the graph of G. So that's not what we want. So how do we write this answer? You see, again, guys, when we say determined by any means necessary, so we have a graph, so we can just write the answer only. So we will know that, well, this happens when x is less than, remember it's not included, less than -3. Or when x is greater than 2. Easy. 7.5. So what are we doing here? It is further given that K is the graph of G prime. Now G prime means we've got a G of X, and this should be cubic. This should be cubic. And obviously, this one is going to be negative. So the graph is going to be stuff like that. We don't really care how it goes, but this is what we get. Because we saw that this one has a negative coefficient of x squared, and that would mean the coefficient of x cubed is also negative. Okay, great. So now this is an application of calculus. Can you see, even though calculus was still to come, it's already being brought here. So in maths, anyway, a question can be asked and it needs you to respond. Okay, let's quickly get to this one. So we have 7.5.1. It says, for which values of x will the graph of g be concave up? Okay, nice. Now we can look at the gradients of this function. The gradients can tell us. Okay, so the first derivative function, the gradients on this side are positive. The gradients at the turning point are 0. And the gradients below that are essentially positive, sorry. So this is positive gradients, that is 0, that is negative gradients. Now we know that when the first derivative function takes positive gradients, the graph becomes concave up. Okay, so this is when x is less than -1. So this is very easy again. So we can say when x is less than -1. That's nice. Or some students trust their algebraic manipulations. What are we going to say? We can say here, well, the second derivative, or maybe we can just say k prime of x should be greater than 0. Meaning the gradients must be greater than 0. We differentiate that, get -4x, -4 greater than 0. This implies -4x is greater than 4. Therefore, x must be less than, because we are dividing by negative, this becomes -1. So one can use differential calculus, differentiation, and of course, understanding what is going on here is important. And here, basically doing the actual derivative and then solving is going to give us the 2 marks. Okay, so that's an option. All right, okay, all right. So that's essentially the story, guys. And now what else do we know? We also know that the x coordinate at the turning point is the x coordinate at the point of inflection. So this means this is where concavity changes. Can you see? Now we know that below that point for a graphy face, the graph is concave up because it's going to be like this. Okay, so maybe let's draw our sketch a bit better here so that it can send the right message. So essentially the graph would look something like this. I mean, it doesn't really have to be accurate. Aibo, so basically my point of inflection is showing up there, -1. This is it. So this is where the concavity changes into that and into that. Okay. So there's a lot of things. One can use the turning point of the first derivative. One can look at gradients and all that, as long as it gives the answer, because this would be the graph of G. Okay, easy. Whether this is accurate or not, it's not a big deal at this moment. And then we are told to sketch the graph of G. Okay. (7.5.2). We need to sketch the graph clearly showing the x values of the turning point and the point of inflection. Okay, so that's fine. Okay, so this is going to be our origin here. Okay guys, so this is what I can do. And now we're supposed to show the x values at the turning point. We know that the x-intercepts of our parabola are basically the x-coordinates at the turning points. So this was -4, this one was 2. Okay, great. And then we need to show the x-coordinate also at the point of inflection. So this could be somewhere here. I mean, this sketch could be either, I mean, it could be negative, it could be positive. I really don't know, but it will depend on some other things. We might want to check that out, but this is it. So this is G. So we get a mark for that. We get a mark for that x-coordinate of the point of inflection, no matter what the corresponding y value. We were not interested in the shape of the graph. So that is how we score those 3 marks. Okay, so obviously, guys, here you know that this could be negative, it could be positive. This would also depend on the y-intercept and many other issues. So we leave that at that, because a sketch is not really that much accurate when we don't have the specification of the graph itself. Okay, the y-intercept could be even negative, you never know. So we will see, we will see, we will see. Okay, guys, so that's a very nice question. Now I'm feeling a bit beat. I need to eat. Now a quadratic function has the following properties. Okay, now this is one of those typical higher grade questions where the student may want to cry. Okay, the function is symmetrical to this one about the y-axis, meaning it is a horizontal reflection. Okay, symmetricality about, this is a flip, it's a horizontal reflection. So horizontal reflection means this sign will change. Okay, why does the B sign change? Because remember, horizontal reflection means we're multiplying by negative x values, right? Now because this one is squared, it doesn't change, but this one will change. Okay, but the y-intercept doesn't. Okay, that's number one. The function is symmetrical about, meaning this is the axis of symmetry of the actual function. Okay, that will actually tell us something about the a value, because now we want a. It will tell us stuff about a. You will see how. So, and then the function has a value of -20 when x is 4. So this is just a point where we have 4 is to -20. So this is just a point on the graph. So please be able to interpret pieces of info that is given to you guys and be able to use it. And of course, you can see this is the question typical of also NBT, because NBTs typically choose the higher order questions essentially. But there may be some weak ones, but usually those that are inclined between higher grade and standard grade and more higher grade are the ones that are usually chosen for that exam. Okay, all right, okay. So if you watch my NBT videos, this becomes a piece of cake. Can you see, guys? Don't limit yourself to a particular exam. Just look at the subject, whether NBT or DBE, Limpopo, KZN, Eastern Cape, you know, you name them. It just works. Okay, guys, so now what is the question here? We are told to show that C is 8. Meaning the question is on C. Okay, we need to show that the y-intercept is 8. So it's one of those questions, you know. It's one of those questions. Okay, let's just show it. We can just say the function is going to be such that, maybe let's just write it this way, will be such that y is equal to, this one doesn't change, ax squared, but this one changes because A horizontal reflection, it means we multiply x what do we see? We multiply x by -1. So that is the action for a horizontal reflection. So if that is the case, it means we say minus x times -7 is going to be plus 7x. But here minus x all squared is just x squared, so nothing changes. Remember that. And then the constant doesn't get affected. It's like this. So this is very important. Because of symmetricality or symmetricity about the y-axis. Okay, please understand transformations. Okay, good. Now we know that the axis of symmetry, we can say also, we understand that x, maybe let's write it, we can say the axis of symmetry is such that x is equal to 1. But how do we find the axis of symmetry? It's going to be minus into 7 over a. Sorry, 2a. This must be -1. This is -1 over 1. Nice. So what do? We cross multiply and solve. -1 uvele picking go. Now in fits. So what do we see? This implies that 2a is -7. Therefore, a is -7 over 2. Okay? Okay, all right. So this is saying this is a grumpy face parabola, so to speak. Okay, so great. So this gives us the a value in a way, because we already have the b value there. All right. Okay, all right. Now that we have this, we can say this implies then that the function is going to be y equals, now we can write it, -7 over 2 x squared plus 7x plus c through the point that is given, 4 and 20. This means 20 is equal to -7 over 2 into 4 squared plus 7 into 4. That gives us c. We can just make it nicely there and say c is going to be equal to 20 plus 7 over 2 minus 7 into 4, which is equal to what? So 20 plus 7 over 2 minus 7 into 4. That gives us a 9 over 2. Wait a minute. Kutheni ngaphumi? Ifanele uphuma kaloku, guys. Oh yeah. Problems of my own creations. Substitutanga kakuhle. So this is still 4 squared. So this is 20 plus basically 7 over 2 into 4 squared, okay, minus 7 into 4. 48. Teni angaphumi ngoku. Masingaqhelani wena man. Kanti kwenzakalani? So it means A urongo phayana. U-A wethu ufuna ukuba rongo ngoku. I don't understand. 1 12 48. Yes, it's minus 20. My lord. Yes. Incorrect substitutions will head, okay? Can you see, guys, when something doesn't add up, at least can you see this is a protection. It's a protection fee. To say whatever you do, you must get that. If you don't, it means something is wrong. So this is minus 20. Incorrect substitutions will head. Okay, let's see. Minus 20 plus 7 over 2 into 4 squared. Minus 7 into 4. Indeed, I get 8. Okay, all right, okay. Now, when everything ties up to 8, I know it's all good. Can you see, guys, this is the suplex city of functions, and only big girls and boys can survive this terror attack. All right, folks, so the most important is to write the function. The emphasis is on this sign by understanding that reflection, and then working out the value of a using our axis of symmetry, and then essentially substituting the point, and the rest is a means to an end. The answer was already volunteered, so I would suppose here, maybe there. All right, okay, all right. So this gives us the 4 marks on offer, and this was a very nice 22 marks, honestly, because if you love the subject also loves you, ne? Ikuthanda thandi, ikuranza ranzi, ikuranza kakuru, ikuranza. Hey, kuthiwa ngeShitsonga. Xa ithanda ndiyayithanda qha injalo. So guys, you can see, man, maths is beautiful. Maths is beautiful. Okay, guys, now let's crush this party right there. But counting your food to measure something to eat and recharge my tablet. I think my tablet is going to lose its power. I don't know. You never know with these power outages that are unexpected. So let's just do the things. All right, so I've had my water. So let's look at 8.1. Andiswa bought a car for 1.2 million. After 54 months, she realizes that it was a mistake. I mean, honestly, anyone in this day and age who buys a car like that and they don't have money, it's ridiculous. It's only, tenderpreneurs and, business owners and what who can do that, because even to maintain that car is crazy. Anyway, whatever makes you feel better about yourself, go for it, but be careful it doesn't give you some form of depression. These things can be very depressing because they place you under immense stress. Believe me. Be very careful. Don't do things so that people can see you. It's ridiculous. Anyway, let's move on. So, yes, and she saw that she made a mistake in buying such an expensive car and she plans to sell it. Okay, calculate the book value. So once we want the book value, we know that this is the depreciated amount after 54 months using the reducing balance method. If the rate of depreciation is this one per annum. Remember, this is per annum. And we are given months. So this already says we need to convert months to years. All right, to convert months to years, it's going to be 54 over 12. Let's see, 54 divided by 12. That's 4,5. So this is basically 4 years and 5 months. Okay. Of course, learn how to do conversions. So I can advise you, watch Maths Lit videos by Lee, or Distance Learning with Lee. It may be Maths Lit, but how she does conversions is beautiful. So you may want to learn that technique because it can take you far. Rather than my mechanistic one, King Henry died and don't, and you end up suffering. That lady makes it very simple, and I'm sure if you are a pure maths student, you don't choose what maths you're looking at. Even technical maths, look at it. Because guess what? At the end of the day, in your exam, anything from there can be brought, and you will be sweating if you're not prepared. Okay, so this is very easy, guys. So we know that the book value is going to be present value 1 minus I to the exponent n. This means our current value, so 1.2 million, it's 1,200,000 scored, into 1 minus the rate here is going to be, let's do this, it's 3,5 divided by 100, that's 0,035, okay. To the exponent now, this is 4,5. Okay, good. So we can say therefore the book value, okay, maybe we can calculate this first and then we start making conclusions. So 0,035 to the exponent 4,5. So we get 1,022,243 rands 3 cents. Remember, money is to 2 decimal places no matter what, unless someone says something else. But in general, if nothing is said, money should be 2 decimal places. So this is a very easy calculation, guys. So this, hey, what did I write there? This is 4,5, not 45. Incorrect substitutions will hurt. Okay, that is a mark, and then the rest of the substitutions and the answer. Remember, this is rands. If you don't write it, Shesampama, you lose your last mark. Okay, not a big deal. 8.2. Now 8.2 says immediately after the selling the car in question 8.1, Andiswa invests. Now once you hear that word investment, what do you see? Future value. Invests the money in a bank which pays interest at this one, but usually not future value but compound interest. Actually, this is just compound interest. We can call it appreciation rather. It will appreciate, okay? Compounded quarterly. So now this is also another situation that we need to think about now. Okay, great. Now she plans to withdraw. Withdrawals create a nightmare also. Now she withdraws 30 scored at the end of every 3 months, and that is a quarter. Okay, now her first withdrawal will take place at the end of the 6th month. So that means 2 quarters at the end of the 2nd quarter, starting from the day she invested her money. Okay, great. That is T0. So guys, to draw a timeline is something that is invaluable. But if you are a lazy student, you will always wonder how do people do things. So at T1, we are investing this 1,022,243 rands 3 cents. We invest it. Now the terms are 3 monthly because quarters is just, so term 1 is the first quarter. And then we will have term 2 because term 2 is mentioned here. This is the second quarter. At that second quarter, she takes what? 30 squad out. And then she continues to do this until Jesus comes, right? Right, this is what she ends up doing. Okay, we don't know where this ends, okay? But this is just to suggest that even at term 3, because every quarter after that, because she withdraws this every 3 months. So this is term 3. She's taking again 30 squad. Okay. Until term N, which we don't know. She will still probably be taking 30 squad. Okay. All right, so this is what is going on here. So for now, we stop here. So that is the story. And then the interest is at 98. It's 9.8% per annum. Compounded quarterly. All right, okay, all right. So this is the thing. This is the thing, okay? Yeah, maybe we can make this one 1 year, Let's just say term 4. That is the 4th quarter, and make this last one TN. And then again, maybe she will be taking 30 squad out, whatever that is the case. So maybe we can just do this nicely like that. So guys, master the technique. Believe me, it will take you far. But if you don't, you will be mastered by this section. This section is usually easy, but it can be horrible. Now the question says, what will her investment be after 3 months? Okay, that's easy. This is basically the question on term 1. We are saying how much is she going to have here in term 1 from the beginning. Okay, that's easy. It's just a simple compound interest. So we've got 8.2.1. We know that A is going to be P into 1 plus I to the exponent N. This implies that A is, now this is 1,022,243 rands 3 cents into into 1 plus, this is 0.098. Remember, this is a quarter divided by 4 to the exponent 1 because it's just 1 term. All right, so let's see what this is. Therefore, our A is that amount of money. So 1,022,243 rands 3 cents multiplied by 1 plus 0.098 over 4 to the exponent 1. It's just that. So it has grown indeed. This is 1,047,287 rands 98 cents. Okay. So guys, I always try to answer the question. I don't know why I did not do it. Always answer the question. Don't just rush through. Here, we did not answer the question. We just performed a calculation, but nobody knows what A is. Therefore, the book value of the car is 1,022,243 rands 3 cents. Now that is the answer. That is the answer. Okay, let's save some space now. But remember the instructions tell us to leave adequate space between sub-questions. Alright, so we can say therefore she will have 1,047,287 rands 98 cents in her investment at 3 months. That would be the first quarter. So try to answer adequately. Okay, don't do your things and then you start saying that is the thing. It is not the thing. All right. Okay, all right. So doing that nominal interest is a mark, or one can consider substitutions. I mean, it's not a big deal. And then we answer the question. Easy 2 marks there. Of course, guys, in the description, you will find me sharing this question paper together with this memo. There will be a single document so that those of you who would still feel like, hey, pattern May, June, December. From the start, guys, you will be on fire. By the time your teachers teach anything, you will already be on fire. So vutamalanga. Ngoba ndenze ntoni apha ndikucabaye ngolwazi, ndikucabayile njengamalongwe. Ndenza kubeka elangeni wome kamnandi. Sovutha. Upheka imbiza ivuthe ndiyakuxelela. So, yeah, guys, you'll find this memo. There may be some errors in it. I don't have time to look at it, guys. I am super duper tired at the moment. I don't find any joy in wasting my time here. Okay, so let's see. This 8.2.2 says, how much is left in your account after making quarterly withdrawals of 30,000 rands for 15 years. So now we know what is 15 years. So we're going to say 15 times 4. That would be 60. So this is now telling us that this is T60. And remember, she started taking it from T2. And then the whole number of days is 15 years. So I'm trying to think now, how much is left in the account after making quarterly withdrawals of this for 15 years? Now the question is this going to be 15 years of taking this money from second year, and then that means there's more? Well, I know, I'm not sure, guys. Now this is where sometimes you're like sitting there and you want to cry. You're like, is this how it is? Are we talking about 15 years? Maybe, because I mean from 0 to 15 years this would be the case, so I would believe this. But even if the examiner does something else, I think, guys, if you draw a timeline that is clear, I don't think anyone can victimize you, because some statements are not very clear. Because we are not sure that it's 15 years for, I mean, this is within 1 year, actually. The first 4 quarters are within 1 year. So I would believe this is correct. Yeah, it should be correct. Be very careful. Be very careful, guys. Things can go south here. Alright guys, so what is the story? Remember, these are money we took out and they will come out with some interest in them. So, and you can see these are sequential amounts. So every time we're taking something out. This is some reverse future value situation here. So obviously we want to know how much money is left. So we can say money left is going to be equal to the present value of 1 plus I to the n minus x. That would be the future value of these amounts of money with their interest, right? So this is x. I isn't papela when 1 plus I to the n minus 1 all divided by I. So this is what comes to mind when I see this question. Could be wrong, could be right, it doesn't matter. Whatever you think, just go with it. Sometimes it will work, sometimes it won't. Okay guys, maybe we need to drift a bit because we will be in trouble here. This is going to be equal to, now what was the amount initially? 1,022,243 rands 3 cents into 1 plus 0,098 over 4. Now we take this, we subtract that, we add 1, right? Because that is the compounding periods there, so there will be 60 here. Then we subtract, x is 30 squared into 1 plus 0,098 all over 4. But how many quarters? We started taking it on T2, so we're going to say 60 minus 2 plus 1, that's 59. So again, the trick here is knowing how to do this, guys. If you don't, you are in trouble. You will be in trouble. So, so what does this give us? It gives us what it will give us. So the money left is going to be that. Sorry. Okay. So let's try. 1,022,243 rands 3 cents into 1 plus 0,098 divided by 4, and then those will be 60 quarters to the exponent 60. Yay! Minus 30,000. Please guys, be very, very, very careful with your substitutions here. These calculations are designed to be horrible. The problem here is paying attention necessary to sort this question. So we can see that one is going to be basically 59 withdrawals essentially, and they will disappear with some interest. So please guys, do the things meticulously. Don't be in a hurry when you're doing financial math, isn't it? Unless you hate money. If you hate money, then you can do it. So the amount of money left, it's still a lot, eh? It's 485,000. Okay, 439 rands 56 cents to 2 decimal places. Remember, this is money. So we can say money left in investment, or whatever money left, that is fine. Imali eshiyekile, yaqonda. So this one is a bit silly, né? So I think guys, this should be a mark. and that should be a mark. Okay, that should be a mark. Now any one of these two, guys, any one of these two, this here or that there, or maybe both, should be the extra mark. Okay, I believe so. So what is this? 4 marks in the bag. Okay, can you see? This is a higher grade question. This is a higher grade question. No standard grade pupil would know what to do here. But of course, a well-taught student will not even cry when getting here. They'll just be like, okay, all right, okay. I see here. I see what is going on. Because this person just took deposits out instead of adding deposits, you see. So this is essentially grade 11 reversed into grade 12. Okay, guys, easy. Now let's do the last question. So 8.2.3. What is here? Calculate how much interest she would have withdrawn after making such withdrawals of 30,000 rands for 15 years. For me, guys, what I would think is that, remember, when we're taking these 30,000, we have not considered interest per se. Right. So what I would think is, how much interest will she have withdrawn? So in my opinion, I could just take the future value of this and subtract the multiplication of those withdrawals and see what we get. So we can say interest would be equal to x into 1 plus I to the n minus 1 all over I minus, we can say here p, or whatever that value we will call it. Maybe let's call it p into n. I don't know. This is what I'm thinking. If I get the future value, remember this will be the money with interest that is taken out. Then we subtract the money that was without interest. Then that leaves us the interest withdrawn. Ne? Very nice question, I suppose. So this is going to be 30,000 into 1 plus 0.098 over 4. Now these ones were 59 minus 1. All divided by 0.098 over 4. Then we subtract 30,000 into 59. So this is those amounts without interest. Nah, should work. If we don't get a negative answer, then we are correct. But if we find ourselves with a negative answer, then it means we are in trouble. Remember tate. Wow. Wanting ho bonolo. Ho kena mathateng empa ho thata ho tswa mathateng. Wa bona? Ke nngwe taba nthong ya bophelo ka nnete ke semphekgo ntho ena. Haeba wa ntseba o kampa o utlwa hore ke reng, empa ha o sa utlwisisi he. Tjhe, ke utlwetse. Ke utlwetse ngwana motho. Ha ona letho nka le buang le wena. Hey guys, I get a positive answer. This is 2,112,452 rands 75 cents. So this is a lot of interest. It's a lot, but let's see. How big is 30,000 times 9? 1, 2, 3. Sorry, times 59. Yeah, it's itself on the millions, ne? It's itself on the millions. So basically, this is 1,770,000. Interesting. So the interest is quite a lot, eh? Is that possible though? Can you have an interest that is more than the actual amount? Ingathi ufuna ukungiqhatha ke ngoku. Ingathi ufuna ukungiqhatha kodwa ke I will believe it, guys, because if I get a positive answer, hey, ezinye questions is phambene. You just need to believe what you did and hope for the best. But I think it makes sense what we did. I mean, because these 30,000, we're just throwing them out like that. We're not considering interest. But if we combine them into some future value for the time period that this is cooking, I do believe it should be okay like this. Yeah. Of course, guys, you can double check. I'm not too sure here. The interest is so big compared to the amount of money put in. It's strange, but again, this is compound interest. Interest can actually grow faster and bigger for a huge amount like that. So yeah, double check. This is yet another higher grade question. It's a higher order question because it picks your brain a bit. Okay, all right, okay. So we're just scoring 3 marks here, guys. So obviously this calculation, that calculation, and the final answer, I would suppose 3 marks there. If there is no issues, we should have scored those marks. So you can appreciate that, yay, financial maths can do things to you. As much approachable as it is, but can you see the utility of the timeline, guys? If you don't master that technique, I don't know what is your hope in this, because many of you attempt this just by jumping in. You will not win, okay? But maybe your teachers can because they know what to do, but you guys are still shaky here. So do not do things that will put you in a disadvantage, okay? Let's just get to calculus now. Now this is easy. You get to breathe a bit, okay? So we're not going to waste time. 9.1, we have f of x equals 5x squared minus x plus 3. And then 9.1.1 says we need to find the first derivative. This is the limit as h tends to 0 of Sir Isaac Newton's quotient okay. This is what we have. So this is the limit as h tends to 0. We substitute 5 into x, we put x plus h, and then that is squared, minus we put x plus h, plus 3 minus we put f of x, 5x squared minus x plus 3. Okay. All of this over h, okay? So this is the limit. You know, I'm deteriorating slowly, guys. 5 into, we fall this out, this is x squared plus 2xh plus h squared. This is minus x minus h plus 3 minus 5x squared plus x minus 3 all over h. So minus x plus x out, 3 and minus 3 out. So these ones do the things. So what do we have? We have the limit as h tends to 0, we start to sit with the problem. We sort this out. This is 5x squared plus 10xh plus 5h squared minus h minus 5x squared all over h. Again, this one and that one do the thing. They do the thing that they must do. Okay, this is going to give us the limit as h tends to 0. We'll just take a bit of our time here. So what do we have, guys? We've got 10xh plus 5h squared minus h minus, no, that's all, over h. So we can shorten this. It's ridiculously long. This is going to be equal to the limit as h tends to 0, h into 10x plus 5h minus 1 over h. So the h's eventually do it. They do the gracious thing, you know. So this is going to be equal to, so the limit as h tends to 0 of 10x plus 5h minus 1, which is going to be 10x plus 5 into 0 minus 1. That's it. Okay. So guys, ndonqenile ke apho uyiphinda le business. Dayibhiyesach 8s as a lot of work, man. I don't like to do this. Salufa. This is it. So you know that in between you need to write all of those things, right? Right. But sometimes there's no need. Okay. So we know that this is a mark. Yes. Substituting the 0 there. Yes. You know, getting this dude. Yes. But mainly factorization. I think, remember the 3-step approach, factorization, substitutions for this one and that one. Yay. Now everything else is done. So remember 3-step approach, BODMAS, factorize, law or identity. So this is good, guys. It's applicable here. Okay. Don't play with fire. You will burn. So this is how those 5 marks are scored. Easy. Easy, easy, easy. All right. Now let's do 9.1.2. It says, hence or otherwise determine the gradient of the tangent of the, to the curve at x is equal to 1. So we can just say the gradient of the tangent is going to be f prime of x at the x coordinate of 1. So this implies that m of the tangent is going to be 10 into 1 minus 1. This is 9. Okay. How many marks? Just 1 mark. Okay. But remember, the question says determine, so by any means necessary, but I do believe that even though this is 1 mark, you don't have a choice but to calculate it. And sometimes this is a catch, because if you start writing the answer only, I wonder what would happen to you. That means you are disrespecting instructions, that in any calculations show. See, this is your friend. When the going goes a bit fuzzy, aqala nje kuba inkungu emehlweni kwenza into ekufanele uzenze ni. You do what you can do. 9.2 we are supposed to differentiate D with respect to T for that situation. So we have D with respect to T of this situation, 2T minus 1 into T plus 4. So we need to sort it out. This implies that we are differentiating D in terms, with respect to T. We sort this out first. So this is going to be 2T squared plus, so this is 8T minus 1T. So this becomes 7T minus 4. Okay, easy stuff. So now we can say equal to, we do the differentiation. This is going to be 4T plus 7. The constant is out. All right, okay, all right. So be very careful of the notation. So obviously, guys, 3 marks. So those and writing that or foiling it out. Remember 3-step approach? So here we just did Bodmer's FOIL method. Then we did the law of differentiation. Can you see? E-marks buffet. This is basically the key when you are doing maths. Marks are scored mostly around these kind of things. All right, okay, all right. So that was an easy 3 marks if there's no mistakes. 9.3, we need to do dq. We differentiate q with respect to p. Okay, now let's do this. Now remember, if this is the case, this means we need to look at what is on the numerator. What is on the numerator is the subject of the formula. So this becomes the subject. Okay, so let's see. We have p squared. No. (9p squared minus 3pq minus q is equal to 1. Then we want to make q the subject. So obviously here we need to do factorization by grouping. So this implies that we've got 9p squared minus, and then here we can pull out a negative. What do we end up with? We end up with 3p plus 1, and then we take q out. Right. Equals 1. Okay, now we need to just simplify. That is Bodmer's. And we're factorizing. See, that is the story. Now we can see that, well, we can take this to the other side and then that. So we can see that basically this is going to be 9p squared minus 1. Okay, so we divide by 3p plus 1. What do we see? Q is going to be 9p squared minus 1 divided by 3p plus 1. Now if we look here, this is a difference of 2 squares. Right. So this also implies that Q is going to be essentially 3p minus 1 into 3p plus 1, all divided by 3p plus 1. Okay, now we can see that these brackets are the same, so they will divide nicely. It divides nicely into just defining that Q is basically 3p minus 1. It's linear. So if that is the case, we can say therefore d of Q with respect to t, to p, is going to be equal to just 3. The constant is out. Can you see, guys? We just went about our business. BODMAS, first of all, we just saw these things. In fact, not BODMAS as yet. We started with factorization by grouping. Then we moved things around. And then we went on our business. And then we realized that we can still factorize again, difference of 2 squares. And then we use the law or an identity. So where are we going to get these marks? This one is important, right? And essentially getting this one right is also important. Factorization here using the difference of 2 squares is good. Factorization by taking out the highest common factor is good. That is those 4 marks. See? Not such a painful exercise. So this would give you easy 13 marks. Remember calculus, guys, this is where you just take full marks. Please get 100% for a question like question 9, where you use rules and what. Just get those marks and move. Get them and move, okay? Get them and move. Okay, guys. Whew, the guy is super duper tired, but let's just go on. I cannot afford to lose time anymore. Question 10. Okay, we're told here the graph of the second derivative is linear, is sketched below. So that is the y-intercept, that's the x-intercept. So already we know that the gradient is positive here. And in fact, we can even look out for it. This is going to be 6 divided by 1. So this is 6 already. So what does that tell us? It tells us that the second derivative of f is going to be 6x plus 6. Easy stuff. So please, guys, don't need a second invitation for certain things. Just have it in mind somewhere. Then what do we see? F of x is a cubic function, and it's also very strange looking here. You're only given the y-intercept. Okay, the rest is unknown. Okay, now we're told the graph is decreasing between these ones. Now, what do we see? If the gradient of the second derivative is positive, it also means that p should be positive, because that would be the coefficient of x cubed. It always goes the same line as that. Okay, so we know that p must come out positive. Now, if p is positive, it means our graph is like this. So it means our graph is expected to be stuff like this. Okay, nope. So we expect something like that. Of course, this is just the expectation at the moment. because when a is greater than 0 or the coefficient of x cubed is greater than 0, the graph is going to be like that. Okay. Oh yeah, the y-intercept is negative, so oops, wrong. Remember, you try to draw something near perfect, so this could be something like this. Okay, this could be something like that. Nice and easy. So this is what we are thinking, and we are saying these are the turning points, because we see that this graph will decrease about those turning points. Okay, so this means this is 1, and that is t. Okay guys, so that is what we expect. And now what do we know about the x-coordinate of the second derivative function? It gives us the x-coordinate at the point of inflection. So this is stuff like that. So we know that this is -1. That would be -1 over there. Okay, giving us the boy. So this would be the point of inflection. Very important, and we can see the y-intercept is negative, so that is fine. This is exactly what we are getting. And we can see the graph carries negative gradients between those two turning points. 1 is 1, so this is giving us the turning points. But now t needs to be looked for. Okay. Well, it's very easy to find the other one, because remember, these ones are symmetrical. If this is 1 here, for example, the distance from that to 1 should be the same as the distance from that to the next one. Okay, so this would mean around there. How many is this? This is 2 units. So -1 times 2, that gives us -3. So this is literally suggesting that t is -3 there. Very important, because these are symmetrical about that. This is the axis of symmetry of the first derivative function, where those coordinates become the x-intercepts of the first derivative function. Very important stuff, folks, to notice. Okay, so this is the story. So this is literally -3 over there at t. So we can even push this one out and say that should be -3. Nice, 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 nice. This is great. Okay, so this is it, folks. So we have an idea of what is going on in here now. Of course, this is our function f. So remember, guys, with these questions, take a moment to look at it and make sure you understand what is going on. Okay, so we know that when the first derivative function starts to take positive y values, what happens? Positive y values, this is concave up. Ne? Yes, and look at that. Just look at that. This would be concave up from here. Okay? And then when the second derivative function takes negative y values, because we cannot use the gradient, it's constant. When it takes negative y values, what is our graph? It's concave down. This becomes concave down. Can you see? So there's a lot to consider, but we can see and appreciate what is going on in our graph. All right, now guys, let's not waste time. Let's solve. Once we have made a bit of an analysis, determine the equation. This is easy. So an answer only can be marked because a determination is by any means necessary. So we can just say the the second derivative of f is going to be, the gradient here is positive, and we can see that this is 6. We did it already. And then the y-intercept is 6. So an answer only 2 marks. But you can show the calculation, the standard approach. It's not a big deal. When the question is free for, doing the things, it's free. We can use inspection because we've got x and y coordinates. Now it says write down the x value of the point of inflection. This is easy. X is equal to -1. It is the x-intercept of the second derivative function, or the x-coordinate of the turning point of the first derivative function. So this one is just an easy 1 mark. 10.3, it says use the graph of the second derivative to determine the values of x for which the graph is concave up. Can you see? There is a clear instruction here. You can't do calculus, you can't do anything. You just use this graph to use, okay, maybe you can use calculus, but the thing said the graph, not the equation. So be very careful, guys. There's a catch to these questions. You may lose this 1 mark if you're not serious. Now, what did we say? When this becomes concave up, when what? It becomes concave up when the second derivative function is greater than 0, when it takes positive y values, and this is greater than that x coordinate of the point of inflection. So you can just simply say when x is greater than -1. Again, we get another mark. So an answer only is acceptable here because we are already using the graph. No one said use the equation or any other ways. Use the graph of the second derivative function. So you can lose that mark easily if you don't adhere. So there's no other option here. You use the graph. 10.4, it's one of those questions again. So this is a higher grade question because standard grades would choke on this one and even die. Okay, we need to show that p is 1. We knew that p must be positive. And of course, guys, this is from the Northwest. This question came from the Northwest prelim. (2022). Okay, I did this one in the channel, so be on the lookout for this question. It's there. This one looks familiar, but I'm not sure. Bandadita tape. Maybe May, June 2022. That supplementary exam. I think this one came from there. But just check these things out. They are already there in the channel, but it's also good to review this on this tablet because it gives us a bit of a play than it was with that one. But I also showed you how you can use your pen and pencils to also do this on the actual paper because you're not limited to the tablet, ne? Okay, let's go for it, guys. 10.4, we know that. Okay, all right, okay. F of x is px cubed plus qx squared plus rx minus 27. This implies that the first derivative function here is going to be 3px squared plus 2qx plus r, where the 27 falls away. This also implies that the second derivative, so we're using our rules, 3-step approach, using rules now of differentiation. This is going to be 6px plus 2q. That's it. we've got a story, but we know that the second derivative function is given by 6x plus 6. Now logic would say the gradient must be that. The y-intercept must be that. So you can say this implies that basically 6p must be equal to 6 and 2q must also be equal to 6. Therefore p is 1 and q is 3. Nice and easy. So it's done. It's done, guys. Shayile. So now the missing guy is this one. So what are we going to do? Remember. We know something about the first derivative function. Its x-intercepts. Its x-intercepts is going to be that and that. And we used the axis of symmetry to get this one. Okay? This one was already volunteered, so we didn't sweat. So we can use that knowledge. But then, okay, this one says hence or otherwise get t. So we can't use that. But we can use this one. Yeah, we can use this one. We need to use that x-intercept of the first derivative function because this one, according to the situation, is still elusive. Okay, let's do it. We can say here then what do we know? We know that Bafetu, the first derivative function is given by 3px squared. Okay, maybe let's just substitute the p already. This is 3 into 1 x squared plus 2 into 3x plus r. We can say this one, we understand that this is the x-intercept. So with this point like this, we know that this is 0 equals 3x squared plus 6x plus r. We substitute. Plus r. So therefore our r is going to be, this is 3 plus 6, that's 9. So when you transpose it becomes minus 9. Kitching. Now this one is elusive. You needed to know that it came from, it came from that inequality there. If you don't interpret these graphs with that knowledge, you are dead, because this is a higher grade question, as I said. You can't crack this one carelessly. Therefore, so we can say therefore P is 1, Q is 3, and R is minus 9. We need to answer the question. Eventually. A very nice question, really, because it picks your brain heavily. So this is 5 marks, guys. So we get a mark for this. Okay, the marks, I mean, these are already given. But I think this is key, this is key, and that is key. 3 marks. Substituting this point is the 4th mark. Okay, maske sicinge futhi, maske sicinge bakwenzeke ntoni apha. Yeah, maybe doing the first derivative using the rules, that should be 5 marks. Okay, this can be quite hectic, but you can look at the marking guidelines on this question in that question paper. You will see the actual distribution of those marks, but work is work, guys. So 10.5. It says hence or otherwise determine the value of t. So we know that, well, t plus this other x coordinate over 2, it's going to be the average, it's going to be giving us -1. We're just using that symmetry. So this is over 1, we cross multiply and transpose. So we can say therefore t is -2 minus 1, which is -3. So we're just using the fact that that would be the axis of symmetry. And if it says hence or otherwise, we just go for it. So I'm not going to waste time, guys. This is good, this is good, and that is good. 3 marks. But how else could you do it? Well, the other option you have here is to take the actual first derivative function and equate it to 0. So you can say f prime x must be equal to 0. Now this would imply that we have 3x squared plus 6x minus 9 equal to 0. This implies that we've got x squared plus 2x minus 3 equal to 0. We substitute, we factorize x plus 3 minus 1. You can see here that you can make a conclusion that therefore x is equal to 1 or x is equal to -3. You can make a conclusion, therefore t is -3. So algebra. So we equate this to 0, we factorize, remember 3-step approach, and getting the answer. Easy, 3 marks. Okay guys, let's not prolong this one. There's many other ways you can look at, but the most important is to get the answer right. So we have 10.6. Now this says for which values of x is f of x greater than 0. My throat is throating. Now when is it greater than 0 or equal to 0? Okay, we can see that, well, we don't know because this is a sketch. Remember that sketch is careless. There wasn't much. So this means we need to find the x-intercepts here. The hint, find x-intercepts. Now, how are we going to do it? Remainder theorem. Can you see what I told you guys? So we need to find a factor and then write f and then get the quotient, and then of course if this is a factor there would be no remainder. Then we can factorize and then we can look at the graph eventually. Okay, let's see. F of x is basically, we know p is 1, so this is but x cubed plus this one is, we got q as 3, so that is 3x squared plus, okay, we got r as -9, so we've got -9x minus 27 because that was given. So now we can use our calculator. Let me just show you the quickest way to avoid trouble. But this should be on your rough work, okay? You don't need to show this. So in your calculator, you go to mode, then it takes you to equation, then it takes you to the standard format. Okay. And then all you do, you input those values, you use the coefficients. So we know that A is 1 from there. We know B is 3. From there we know C is -9. And then D is -27. So you input those into the mode. So let's go. Mode. Equation is option 5. Then that one is option 4. And then A is 1. We press equals to move. Then B is 3. We press equals to move. C is -9. We press equal sign to move. And then D is -27. Now we just press equal sign. It gives us the first. It gives us that x1 is equal to 3. And then we hit again. It gives us x2 is equal to -3. When we hit this, it disappears. So it means in one of these there's equal roots. Okay? So it's either the equal roots are here or they are there. But once we don't get the third one, it means there's an equal root here. So is it here or here? Okay. This helps a lot to plan your way forward because trial and error can hurt. So we already know that basically -3 is a factor. So if we choose this one, we can say here, we know that, well, f, maybe we can just say, but, remember we're in conversation now, f of -3 is equal to -3 cubed plus 3 into -3 squared minus 9 into -3 minus 27. Let's see. This implies that f of -3 is. Now we go back to the computing mode, which is option 1. So what do we see there? -3 squared plus 3 into -3. So you know that this one is going to give us 0 anyway. So telling at impala into engekho ngoku. Let's go back. Right. So we've got -3 cubed, right? Right. Plus 3 into -3 squared minus 9 into -3 minus 27. That is indeed 0. So we just show this one. We do the rest of our trial and error in our rough work. Here we need to present the approach. So we can say, therefore, it means x plus 3 is a factor of f. Nice. Now what does that mean? This implies that basically f of x is going to be x plus 3 into, we know the other one is going to be quadratic, so we look at it. If we want x cubed, this must be x squared. If we want -27, already have 3, so this must be -9. Okay, nice. And then we can just focus on any one of the middle terms. I like that one, it's much easier. So I know that basically this multiplied by that and that multiplied by the next term must give me -9x. So this is already going to be -9x. So now I need plus 18x. So this must be plus 6x here. Okay. So we can say this is 18. Wait. Emanyana. Ibatla ho nsukudisa jwale. This is not working. It's not working. So this is minus 9. I need plus 18. But no. This cannot work. It can't be 6x therefore here. Because therefore it means there must be 0 here, right? So there must be nothing. There must be nothing because I already want minus 9x. So there must be nothing. There must be 0 here, so this term does not exist. If this is what we're doing. So be careful when things don't make sense. Look at it. So this is minus 9. Again, this is parabolic. It's the difference of two squares. Not a big deal. This implies that x is equal to, this is already highlighting the fact that we're going to have equal roots here. So we've got x plus 3 into x minus 3 into, maybe we can just put this one and say x minus 3. Can you see? We had equal roots where x is minus 3. So this is here. So this already says our graph needs to be changed. Oops. Ah, Lord. Maske sithathe yonke sibone bizawuthatheka na. Sihlisa. Cacile uba there's equal roots there. So sishiya kanje. Okay, this means our graph is like that, guys. It's going like that. So this one is out, that one is out. So our graph is here. Okay, so we see that our graph is there. Okay, that is the graph. Literally. So we can extend this one. So this is how our graph looks, guys. So can you see? Yo, msebenzi omninzi. 10 more is unclear. No? That's much better. So guys, this is minus 1. Now this comes out nicely there. And then we can remove this one from the bottom here. And say that is minus 3 over there. We are good. And then we can move this guy. So we know that this is minus 27. Over there, and then that is our boy. Can you see our point of inflection is on the right position now? Okay, so this is great. And we can see that when x is minus 3, this would take us to 3 over there. So everything is there. Now we can see from the graph that essentially this graph is going to be greater than 0 in that segment. It is greater than 0 in this segment, and that means it's all these x values going in this direction. Okay, because everywhere else it's less than 0. But it is also equal to 0 there. So we need to consider two solutions there. So from here, once we have done this, we can just simply say, now we know from the sketch, I mean guys, here what we can do, we can actually copy that sketch. Sometimes we were told that whatever we used to determine our solutions, we must take, copy, and paste. So obviously guys, we draw a neat sketch, not a busy one like mine, but the body is a technique of doing this. Now from there, you're going to say, therefore, now we can make a conclusion. X must be equal to -3, because that is giving us 0. 0 is included. Or X must be greater than or equal to 3. That is also good. So we get a mark for each one of these guys. And then what do we get? What do we get? What do we get for stating that this is a factor? That's what we get. And then, you know, this situation right here is also good. So 4 marks. Now the 5th mark is when we are doing our gymnastic of factorizations. Interesting, isn't it? Yes, 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 yes. Now guys, practice long division. When we have x cubed plus 3x squared minus 9x minus 27 when divided by x plus 3, so get us the quotient, right? Because this is a factor, right? Because obviously it's going to get things out to 0. Okay, some things are just going to fall off to 0. So practice this and then follow on and do the synthetic division. Synthetic division, we take exactly what we substituted, -3, and then we write the coefficients. This is 1, 3, minus 9, minus 27. We let this one through to come here, and then we do the necessary gymnastics. So practice these techniques to factorize that quadratic. I mean that cubic. Practice those. So can you see guys, this revision is good in that I allow you some chance to practice. I have shown you already how these ones work. So this is your chance to play with the factorization using this or that. And then you are good to go. So this is it, folks. This is nice. And remember, this graph is important for this conclusion. Without the graph, there's no stories there. There's no stories, because how would you know that it is like that? You can't check by inspection. Okay, all right. But again, it's controversial. It's controversial. All right, guys. So, of course, making sure everything is done. We've got our 5 marks and we can walk away with some 17 marks. If no mistakes have occurred, at some point you get overwhelmed with the checking. So you can see that yes, yabuya masezbuya, guys. Buyimpela. Question 11. Now this is application of calculus. This is again a question in the Northwest. September 2022. I've already done this one also in the channel. So you can enjoy this in that fashion, or you can enjoy it in this version. in this version. It says a soldier shoots at a fixed target TQ. Okay. There it is, on the crest Now understand mathematical language. That is the highest point or maximum point of the hill. Okay, the height of the hill is represented by this equation. Okay, this is the equation of the hill, and it's a parabola. We can see it, but it's restricted. So this is already suggesting that this is 3 here, this is 1. So it gives us the x-intercepts. And if we drop a line from Q there to get the axis of symmetry, this is going to be between these two. 3 plus 1 is 4, divided by 2 is 2. Okay, all right, okay. So that's what we know. So we will see that the coordinates of Q we can actually determine if we like, but are they going to be helpful? Not necessarily. Now it says P is the point on the hill. Okay, great. Now what do we see here, guys? We will see that there is this business right there. Okay, it says write an expression for the gradient of at any point on the hill in terms of x. The gradient at any point. Keyword is at any point. So this means we need to do the first derivative function of that nicely. But now we just write it down. So 11.1. We know that the hill is h, so we can say h prime x is, we differentiate that, it's minus 2 x plus 4. And the other one goes away. So this is just 1 mark. Okay, 11.2. It says, what is the smallest angle, theta? Now this means minimum. Okay, that the soldier can aim to shoot the target, meaning of the smaller ones. This is the last angle that is small, because you can increase that a bit and take it to the top as well. So this means applications of calculus. So this is another higher grade question. Okay, guys, we move on. So how do we start planning this? We will see that this gradient, remember this is the gradient of this dotted line. But now there is the point of intersection of this graph and the tangent. Okay, so what do we know? The tangent is going to have the same gradient as at P. But now if we drop P to the ground, because we must do it, if we drop P to the ground, this is perpendicular, right? So the coordinates of P, we can say this is some x value, we don't know. So this is x. What would be the y value? We substitute into the parabola. So this is going to be just minus x squared plus 4x minus 3. That would be the coordinates of point P. Okay, so what do we see, guys? What we see, guys, is a right-angled triangle. Yes, that is a right-angled triangle. Now this means trigonometry can come to our rescue here, because we will have the opposite side. It's that coordinate. The adjacent side, it's that coordinate. So life becomes a bit nicer. Okay. So this is what we can think of. So we can do simultaneous equations. This is what makes this a higher grade question. So we can actually focus on the gradient at P using this first derivative function, but that should also be equal to the tangent of theta, and that can help us to find that angle theta. Okay, so what do we know, guys? We know that tan theta, in fact, let's not even use tan theta, let's just use the gradient between S and P. The gradient between S and P should be equal to h prime of x. we know that the tangent and the curve are going to share the same gradient at that point of intersection, as well as that point, of course. So how do we do this? We know that y at P minus y at S over x at P minus x at S should be equal to minus 2x plus 4. Okay, we do this. I mean, you can separate this if you like and then solve for the common factor, but you know what, just do it. Gradient is the gradient. So y at P is minus x squared plus 4x minus 3. So this is going to be minus 0 at S because that's the origin. Even though not stated, you should know it. And then this one is going to be that one at x minus 0 is equal to minus 2x plus 4. This is all over 1. Then our favorite gymnastic, cross multiply. What do we get? Well, we get here minus x squared plus 4x minus 3 is equal to multiply x. This is minus 2x squared plus 4x. Now we can solve for x. We transpose this to the other side. We get x squared. The 4x's take each other out because they are the same on either side. So essentially we get here x squared is equal to 3. Therefore, x is going to be the square root of 3. Remember, x is on the positive x-axis, so we don't want the negative one. And what we did there, we just took the square root easily. We didn't want to waste our time. Nice. Okay, guys, so we've got the x value. It's root 3. So what would be the y value? Now we want the corresponding y value because that will help us a lot. So this is going to be minus into square root 3 squared plus 4 into square root 3 minus 3. So this gives us minus 3 plus 4 root 3 minus 3. So this is minus 6 plus 4 root 3. So this is what we get. Okay. Easy. Of course. So we can say therefore this is the x at P, and say therefore the corresponding y value at P is going to be minus into square root 3 all squared plus 4 into square root 3 minus 3. This is going to be minus 6 plus 4 root 3. Okay, good. So what do we say? We can conclude that point P has square root 3 as its x-coordinate and minus 6 plus 4 root 3 as its y-coordinate. Nice. Alright guys, so what are we getting to? We want to solve the angle. We will say here then tan theta could be expressed in that triangle as the opposite, which is the x-coordinate at P, sorry, the y-coordinate at P. So I'm just going to use that over the x-coordinate at P, because that gives us that story. Right, so tan theta is, this is minus 6 plus 4 root 3 divided by root 3. Easy. So what do we say? We can say therefore theta is going to be arctan of minus 6 plus 4 root 3. Yo, didn't we? Okay, so this is it, guys. So we can just get the value of theta nicely. So we've got shift 10, 6 plus 4 root 3 over root 3 this one, it's minus 6. So this gives us a 28, comma. Now to 2 decimal places is 19 degrees. So guys, that would be the smallest angle. The smallest angle will happen when this line is a tangent there. Okay? Because other angles are going to be a lot bigger if we think about it. Alright. Any angle smaller than this will miss the target. For example, if we draw a line like so, can you see? Any angle less than that misses the target, and any angle bigger than the top of that thing, can you see? It can still be bigger, but the biggest is going to end there. If you make it bigger, you miss the target. So that is it. So know how to do these things and see what is going on. So it's not a big deal. So here we just needed to know how to use applications of calculus. First derivative, but essentially just using gradients more than anything. Okay, that is easy. Sorry, so we know that this is a mark, essentially, and then the general substitutions is a mark. Finding this point is a mark, and defining tan of theta is a mark. The final answer, so 1 2 3 4 5. So easy, 5 marks. Okay, maybe not so easy. This one forces you to think a little bit. So anyway, guys, we are almost done. All right. Okay. All right. All right, guys. So let's go to the end. Yay, when. Okay, I wanted to add some more, but this video is going to be too long. We can't go beyond 6 hours here. Otherwise, it's going to hurt, isn't it? But please do take those 6 hours of revision. Divide it into 3 hours each. So you can do it from 1 in the afternoon until maybe 6, 7, 8 in the evening. Make sure you are going through this actively. Every question I get to, you phrase the thing, you attempt it, and then you see how the solutions come about. You keep doing that so that you don't just watch. Then it will open your mind, okay? Once you are done, what I can suggest is do a rerun of the same thing. Maybe after 8, 9, you just take your break, maybe 2 hours, again from say 10 until 12 or so, or maybe 1 a.m. depending on what you're writing the next day. If you're writing, don't do it, but if you're not, then do that. You just do that rerun for 3 hours and see if you will still be able to manage the time, knowing what you know now about the question, so that you can see that if you see similar patterns in the actual exam, you can cruise. You can be on cruise control, all right? And after that, you'll just practice those difficult sections for you, be it using your textbooks and then taking some past exam question papers. You do what is necessary. There's plenty of videos as well. When you get lazy, you just want to watch something, but you want to keep your brain working. All right, so let's get to 12.1. 12.1 says the probabilities of two events, A and B, are given by P of A and P of B respectively. It is further given that the probability of not A. Now, probability of not A is a complement of the probability of A. So this means the probability of A is going to be 1 minus 0.46. What is that? 1 minus 0.46. Remember complementary events? Yes. So this becomes 0.54. All right. Great stuff. So please know complementary events. In fact, just know everything. I think I highlighted most of questions that require, some theoretical background in probabilities. Now the next one, we are told the probability of A is 3 times the probability of B. So this helps us to find the probability of B. So we know that 3 times the probability of A is going to be equal to 3 times the probability of B. This implies that 3 into 0.54 is going to be equal to, wait, no, this is what this is. 0.54 is basically P of B. Therefore, P of B is going to be 0.54 divided by 3, which is 0.18. Okay, so this is very important. So always use what you are given. So this is P of A or B. So already, if we are given that and we have the probability of A and B, it means the addition rule here can help us to find the intersection between these two, because we don't know whether they are mutually exclusive or not. We just want to check that out. So we know that P of A or B is going to be P of A plus P of B minus P of A intersect B. This is going to be 0.4 equals 0.54 plus 0.18 minus P of A intersect B. That's back 10 in this squash there. So minus the probability of A intersect B. Therefore, the probability of A intersect B is going to be, so we transpose this to that side, it's going to be 0.54 plus 0.18 minus 0.4. Okay. This gives us a 0.32. So if it is less than 1, I'm happy. So there's quite a few revelations, guys. So obviously, folks, you take a bit of a moment to try and figure out what is going on, because sometimes answering questions immediately may hurt because you may not know how to approach the question. Now, the question finally says, calculate the probability of not A or not B. Can you see? This is a question heavily on complementary events. All right. So we will say here, well, P not A or not B is going to be equal to P not A plus P not B minus P not A intersect B. right? So we're using the addition rule, doing the things that we need to do. Okay, now there's some things we need to do before we do this. Yes, remember those were the side calculations just to check some things. So now we need to start again, but I just want the probability of B here, so I'm just going to jump into the thing. So I'm just going to say, well, I know that probability of A is equal to 3 times the probability of B. Probability of A is 1 minus the probability of not A. This is going to be equal to 3 times the probability of B. Now I want to solve that. It's 0.54 equals 3 times the probability of B. Therefore, the probability of B is going to be 0.18. Can you see? As a student, maths, guys, be very creative, because you see there was a lot of work that we did, but apa solving in one step. Now the next one says addition rule. We can say also we know that the probability of A or B is going to be the probability of A plus probability of B minus probability of A intersect B. So this is 0.4 is equal to, now we know that this 0.54 plus, we know that this is 0.18 minus probability of A intersect B. Therefore, the probability of A intersect B will be 0.54 plus 0.18 minus 0.4, which we got 0.32. Okay, easy. That would be the second step. Now we do the last one. We can say then probability of not A or not B will be equal to the probability of not A plus the probability of not B minus the probability of not A intersect B. I the question, but this means the probability of not A or not B. Now the probability of not A was given 0.46 plus the probability of not B. We need to sort it out. So this is the complement of 1 minus the probability of B. Minus this one also is going to be the complement of 1 minus 0.32. Okay, so therefore the probability of not A or not B, if we don't get anything more than 1, this is okay, 0.46. But if we get something bigger, well, we are in trouble. 0.18 minus 1. How? 1 overlap. Yes, 1 minus 0.32. Yikes, I get something good. 0.6. Okay, now I'm happy, because if the answer comes out without it being bigger than 1, then it means our method is right. Although this may have suggested 2 steps, but it looks a bit difficult for me to think about other things. You know why? Because these probabilities are not mutually exclusive. You can see here the probability of A and B is not 0, so it wouldn't work. It wouldn't work. Okay, let's move on. Okay, guys, can I this waiting lambi? So obviously, folks, there's some things here. The probability of A is a mark. The probability of B is a mark. This one is a mark. This one is a mark. So this is a very stingy examiner. Gives you a lot of work for nothing. Okay. Let's leave it at that, guys. It's fine. There's nothing we can do, but also the marks can be considered here. Okay? They can also be considered here because those were not given also. So the examiner can decide where the actual marks go. Okay. Great. Of course, do try other approaches if you can, but sometimes there's no joy in just suffering too much. Just suffer a little. So an experiment to determine the relationship between patients' HIV status and the gender was conducted in how many patients? 160 patients. That's a good one. Totals. The probabilities of the results are summarized below. Okay. Male patients, positive 0.125, negative, we don't know. Inconclusive, we don't know, but the totals of all of these probabilities of being male is that one. Now, probabilities of being female is, those who are positive is 0.25, and we don't know those ones, but the probability of being female in general, whether positive or negative or inconclusive, is that. So this is important. Usually we would do a contingency table where we have totals on this side also. But they decided to trick you now. But also know how to use contingency tables. Now, given that the event of a patient being negative is independent of being male, can you see? Negative and being male. These are independent events. Now, the product rule is being propagated here. Now, the question says we need to calculate the number of patients. We want the number of patients that are male and negative. Now, this is T. So this simply says we want T. Excuse me, guys. If the probability of being negative is like that, so the probability of being negative is going to be these two together. Okay, so basically it's going to be T plus R. That's the probability of being negative. And we're being told that that one is 0.5. Okay, nice and easy. Okay, so what do we do? First, we start with the product rule. First, we're going to say the probability of being negative, right? The probability of being negative, sorry, the probability of an, the probability that the event, given that the event of a patient being negative is independent of being male. Now, being negative is what? Is this one. So those are the negative people. Okay, change the question. Given that the event of a patient being negative is independent of being male. Okay. Now, being negative is this one, right? So we're saying probability of being negative is the probability of T plus R is independent of being male. Okay. Oh, okay. Now this is this. This should come out like this. If the probability of being negative is independent of being male, we're going to say the probability of being male and negative should be equal to the probability of being male multiplied by the probability of being negative, isn't it? That's what that means. Okay, so this is very important. So this is the probability of being male and negative. Can you see? Being male and negative is T. This is going to be equal to the probability of being male in general. That's what's going to be 0.375 times the probability of being negative. It's going to be basically T plus R. So this means T is going to be, this is 0.375 times 0.5. Okay, good. So this is 0.375 times 0.5. So we get a 0.1875. Sorry. So that is it. So, but now remember, we are not looking for this. Okay, we can make this one into one step actually. Now, the probability here is going to be the number of patients, right? Number of patients that are male and negative. So the number of patients divided by the total, that was 160, should give us that probability. Okay, so this is over 1. Then we just cross multiply that. It's going to be 160 into 0.1875. Okay, so we multiply this by 160. This is 30 patients. So we can conclude and say, therefore, there are 30 patients who are there are 30 patients who are male and negative. So please guys, try to answer the question always. Don't just do your things. So obviously this answer is good. Yeah, doch. So setting up the product rule is good. Is nice. And then this substitution is good. And this substitution is also good. The rest is history. 4 marks. Okay, 3. I win. Cool. Okay. So we can just say here substitutions basically. It's okay. It's all right. So that is 3 marks. Not a big deal. Okay, that was not a nice question. Not nice. So you can see this revision was getting a bit hot. Okay, but we've spoken about independent events. So using a contingency table for that, I've also given you some tutorials that you guys ignored. They all stayed below 300 views, and I'm thinking, yo, these guys, they must be clever, ne? They don't need all of this. All right, okay, all right. 12.3 says every client of Native Bank has a personal identity or PIN. It's personal identity number. So can you see now I finally know what PIN stands for. I didn't know. It's personal identity number, okay, which is made up of 5 digits. Can you see how dumb I am? Chosen from these digits, okay, 0 to 9. So how many are they? They are 10. And how are they? It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, not a problem. Okay, let's start. So 12.3.1, it says, well, how many such pins are numbers that are divisible by 2? Suka ngeza quit nje. Higher grade nje zibekwa nje. Okay, and also greater than 500. If the digits may not be repeated. Alange nyaka nyaka nje zibekwa nje, guys. But anyway, you need to handle hard questions so that you can deal with easy ones. You can already see that, yeah. A snip up and flay sliding. Yeah, as what? Okay, folks, what are we going to do? We need to deal with this. We've got 5 numbers. 1, 2, 3, 4, 5. Now, to say greater than, this means we can choose any of these numbers. This must start from here to here to here to here. So those are the numbers that are accepted to begin. So this would be the beginning or the start. Okay? Now to be divisible by 2, this means this must end with a 0, end with a 2, end with a 4. It could be a 6, it could be an 8. This is the end. So it has to be an even number basically to divide by 2. Or a multiple of 2. So this is getting a bit complicated because now there's an overlap between the start and the end. So this means we need to consider 2 situations. 1, 2, 3, 4, 5. Okay, maybe let's just shift it down a bit and say, okay, this is what we need to consider now. We can even say even start. And then we can say odd start. Okay. So what are we trying to say? We are saying what we put here must be an even number. And then what we put here, we are saying must be an odd number. Okay? But what is the restriction at the end? This must be an even number so that it can be entirely an even number. And also the restriction is the same for the both at the end. This must be an even number. Okay, we need to consider 2 possibilities. And then of course what we want is the addition of these 2. Okay, let's have a look at them. Just right. Asihlukanise abakugqibela yo. So at the end, guys, we add those to get the totals. So let's start. If we're starting with an even number, now numbers that are going to give us a value greater than 50,000 is going to be 5. It's 6 and 8. So those are the only two. So we just say two possibilities for that beginning. And then if we put down one even number, how many do we have left? So we're going to have 1, 2, 3, 4 if we cancel 1. So we can say 4. That would be 4 there. Then once we put down two numbers, then we can place these ones at random because we're not repeating. So out of 10, we put down 2. This is going to be 8, 7, and 6. So this is going to be equal to 2 times 8 times 7 times 6 times 4. Okay, we've got 2 times 8 times 7 times 6 times 4. This gives us 3,360 pins. Okay, easy. All right, okay, all right. Now, what is the other one? When we come to odd numbers, how many do we have? 1, 2, 3. So we've got 3 possibilities, and then the even numbers are all together. 1, 2, 3, 4, 5. So there would be 5 here. And then in between, we're going to have 8, 7, 6. This is going to be stuff like that. So this is 3 times 8 times 7 times 6 times 5. So this is 40 pins. Okay, great stuff. So you can say therefore the total number of pins is going to be 3,360 plus, is it 2 times 8 times 7 times 6 times 4. Yo, seyichinjile le number yawena kwenzeka ntoni ngoba 2 times 8 times 7 times 6 times 4. I don't know what happened here, so please guys double check. This is 2 times 6 times 8 times 8. I mean, this is a low-key problem, you see. This could have led to some serious disaster now. This is 2,688 plus, must we double check it since it's a 3 times 8 times 7 times 6 times 5. It's 5040. So 5040 plus 2,688. This gives us 7,728 pins. All right, okay, all right. So this is one of those silly questions, guys. They can create problems. So essentially, yeah, we get a mark for this, we get a mark for that, we get a mark for this, we get a mark for that, we get a mark for the answer. That's how those 5 marks come about. Okay, good. Now this one is a naughty one. It's a naughty boy. It's a naughty boy or naughty girl. 12.3.2. This one says, suppose that pin can be made by selecting digits at random and that the digits can be repeated. What is the probability that such a pin will contain at least one number 5? Now that word at least, it means greater than or equal to 1. So meaning it can be 1, can be more. Yeah, hi guys, so I'm sure if you master this, you are good to go. Okay, let's start first by looking at what is this number. So folks, we can repeat here. Now, for me, we need to know the total, right? The random stuff. We can write it. When this is random, it's 1, 2, 3, 4, 5. Okay? Now remember, the pin here doesn't have, remember this one is different from that, okay? Because this is totally random. Here we're not repeating and we had a specification. So here this is a random. So out of 10 numbers, we can start with any. So this is 10, 10, 10, 10, 10, 1, 2, 3, 4, 5. So this is going to be 10 to the exponent 5. This is 100 scored pins. Okay. How to say born 10 to the 5. Yes, it's 100 scored. Now, this is when we are choosing these at random. But now we want one that contains at least 1. That means 1 or more. So now we need to consider when there is no number 5. So we can say no single 5. Hey mates, whatever fethu izodlala ngawe mawungenangqondo uzabona umhlolo. Xa sithi akekho at all 5, sizoba ngaphi? 1, 2, 3, 4, 5. So xa ingekho 5 at all, kusala i-digits ezingaphi? We only remain with 9 digits. So this is going to be 9. Sorry. 9, 9, 9, 9. Because 5 is missing. So this is 9 to the exponent 5. Okay, 9 to the exponent 5 gives us 59,049 pins. Okay, so this is when there is no single 5 in the pin. This means 5 is excluded. We will only say at least 1 is included and more is included, but now we just want those in here that do not have 5. Then we can say this then tells us that the probability of our event is going to be equal to the number of these things. This is going to be that 10 to the exponent 5 minus where there is none, 9 to the exponent 5, all divided by the actual total, which is 10 to the exponent 5. Okay, this is it, guys. This is it. So so this is going to be 10 to the 5 minus 9 to the 5 divided by 10 to the 5. So this gives us 0.41 to 2 decimal places. We can stop it here. We don't need to go any further. All right, guys, so this was a naughty question as well. So the catch here was here. You needed to know how to handle that. So you can see, guys, and appreciate that interpreting the statements given appropriately leads to a better attempt that may guarantee you some good marks, even if it's not full marks. The fact that you can think, it's important. Okay, so we're getting 4 marks. So this is the one, This is the one. Substitution and answer, because this is essentially a calculation. So I would give 4 marks like that. But again, if you've got the marking guideline of this paper, please do check it out so that you can see if I did not lie to you. If ndixokile ke guys, nanizobona uba ke kwathini ndize ndixoke ne. Ngoba ke zezinye izinto ezivele zenzeke zivele uzifumane uxokile nje awuzazi ubuxokela ntoni. These are parts of being a human being, you see. I mean, if the probability is less than 1, I'm happy. I could be wrong about this one, guys, so go and ask the best about this one. I'm not too sure if I'm getting it right, but this is what I'm thinking. This is what I'm thinking, so go ask the best, like Mr. Chauke and many others. MV Tutors, NTE, Bright Young Brains, Mr. Ngosi, Kevin, you know, Math and Science Tutor, Math and Science Aid, you know, long distance, is it long distance learning with Lee, virtual tutor, Mr. Amin Hendricks, you know, who else am I leaving? Batande and Artie, those are the good guys too. This is just me, guys, trying to plug you with the best also. So you might want to look at them, especially the ones that you guys don't pay attention to. Please do that. Start doing that for yourself, especially if you feel grumpy about your marks at the end of this year and you feel like, I want to rerun this thing. So please make it a point that you check those guys out early, even during December holidays, instead of depression because you don't think you performed well. Rather preoccupy yourself with the flexing of your brain and preparing for that May-June exam. And if not even that, also look into doing it again in November, because you might just go there and score 100% in your paper, of course. Then your SBA can do a little bit of a deduction, but you will still stay with a distinction. And you can get to what you want, isn't it? Yes. So, but don't look into doing it again next year. Try your best so that you do it now. But then if it didn't happen, no stress. Take it another go again next year. And please use these channels, guys, as early as possible. Don't do this last minute thing of bumping into a video that is probably not even going to be relevant, and you are all there and wasting your time and you wonder why you fail. You do this early, and anyone who posts late, you should be worried yourselves, because are you going to learn anything there? I doubt. But you might, if you are already sorted in most of the things, then that little bit of extra can add some value. But if you're already blank, trust me, those ones are usually useless. In fact, they chow your time. And even this video is almost too late. It's almost going to be useless for many. But then I tried to stretch it and do as many concepts as I can fully, so that you can appreciate the complexity with which certain questions are asked, and what is the best approach in attempting them, and what is in the bag that you pull out each time you need it for a particular question. So if this is not good enough, guys, I don't know what is, because if you can take this video of mine as late as it is and you focus, I cannot believe this, guys. I was wondering why iphelile lento. I just started somewhere in the middle. Yo, this is crazy. Okay, I will edit this thing nicely. Okay, so guys, you're going to find this memo in the description. It's downloadable, and I will attach the question paper as well for those who want to practice this paper alongside me and use my video for a comprehensive overview of those answers and maybe some learning points as well. then you rerun this thing again, I'm telling you, you will go and ace that exam. Trust me. Your pass is going to be effortless, and a very decent mark like 60s and more would be effortless. A distinction will still require you to crack those higher order questions in the question paper that you're going to sit with. But I can assure you, if you understand what we did, and you know maths is pervasive, meaning concepts from paper 1 apply in paper 2 and vice versa, and don't limit yourself in anything you do, you will be exactly fine. All right, guys, let's cut it here. I will see you some other time. Goodbye and good luck with your exams. I cannot say more on how you can prepare. Just do your best. Cool. I will see you later, if not at all.